Okie doke. Hey everybody, I can see people are still coming in, so we'll just wait here a second. Thanks for taking the time today to join this workshop. I'm Corey O'Daniel, CEO and co-founder of MassDriver. We're one of the companies behind the open source fork of Terraform, OpenTofu. If you are new to infrastructure as code, this will still be a good workshop for you. We also just recently finished, or tomorrow we'll be finishing a 10-week, 1-hour-a-week workshop on getting started with OpenTofu and infrastructure as code. So if you are completely new and you're here today anyway and want to kind of take a full-on getting started workshop, we have that shared on GitHub and on YouTube. So those are free. I would definitely check them out. And we can share the links here in just a second in the chat. We also have another workshop that we're hosting December 18th on generating infrastructure as code from existing cloud resources. So we'll take OpenTofu and some cloud resources that we've already set up, and we'll walk through how to generate IaC and then kind of back it out into modules that you can use to manage multiple environments. You can see that folks are still coming in, so I'm just going to go ahead and I'm going to put those links in the chat now while people are coming in. So I'll be back in just 1 second. Okay, there we go. And I dropped a couple of those links there. So there is the OpenTofu Foundations. That's the 10-week course if you're new to infrastructure as code. And then the StreamYard link there is for the registration for our Generating Infrastructure as Code workshop. Looks like we got a handful of people in here, so I think we can go ahead and get started. So I think this might be up to 4 hours working through the whole thing. We'll kind of see. It really depends on how many questions we get, but I've set aside 4 hours today. So if we finish early and anybody wants to just hack and work on some stuff, I'm happy to hang and answer questions. As I said earlier, I'm Corey O'Daniel, CEO and co-founder of MassDriver. Over the years, we've had the privilege of helping dozens of organizations ranging from startups to larger enterprises scale adoption of infrastructure as code across their teams. And one of the biggest challenges that we've seen is balancing that need for developer self-service with the operational standards ops teams are responsible for. By building on the patterns and practices we'll cover today, you'll see how some of these teams that we've worked with have seen reductions as far as 89% in the amount of time they spend managing their infrastructure as code. So one of the things I think is pretty interesting about this space is looking at some of the latest surveys like the state of CD, state of open source. Only about 20% of developers have experience with infrastructure as code, right? And so when we're in this new era of, GitOps, everything in the cloud, self-service, it's kind of hard to get there when only 1 in 5 developers have that experience, right? And so can we constantly be putting more and more and more on developers that already kind of have a full plate? And I think the answer is no. I think one of the things that we need to do as an industry and as operations engineers is figure out how to build the right abstractions for developers so we can kind of lower the surface area of the cloud and get it into the terminology that they understand. And that's kind of what we'll be going through today. These aren't just ideas, they're battle tested. What I'm sharing today is a practical approach to infrastructure as code that focuses on actually developing software as an ops engineer, right? Making IaC intuitive, scalable, and aligned with your organization's goals. So the focus today is on how to make IaC work not just as a technical implementation, but as a design philosophy that empowers teams to move faster while staying compliant and secure. We're going to learn about designing modules that are, sorry, I meant to start a timer a little earlier. We're going to learn about modules that are intuitive, scalable, and aligned with your organizational standards, all while reducing that operational overhead. By the end of the session, you should be able to apply these principles to your own infrastructure workflows and drive better outcomes for your team. So we'll go ahead and kind of kick it off. And so what I'm going to do is there's going to be a couple of slides. We'll switch to some code, kind of go through a a lab, and I'll share the code here as well. Let me just hop over and grab that link. So this is the full workshop. I'll drop this. Hey, Andreas, how's it going? Andreas is in the 10-week workshop. Glad to see you. So that's the full workshop. And so what we're going to start with today is we're going to start with this base module. And then there's about 6 labs that we'll go through. And each of the lab folders in there is essentially like a completed version of each of the exercises. So if you want to code along, I'd say start with this base module and we'll kind of code together. If you don't want to code because you got other stuff going on and you just kind of want to see as we move from lab to lab, you can kind of hop from one directory to the other and see what's changed and even do like a diff between those directories to see what's changed between the code. So we'll kick things off with one core principle to this workshop, and that is something we call use case oriented design. And at the heart, use case oriented design is about designing infrastructure as code modules to solve specific meaningful problems rather than attempting to be a one-size-fits-all solution. If you think about a module that tries to do everything, it ends up being bloated, very hard to use, and even harder to maintain. On the other hand, when you kind of scope modules down to very clear use cases, they become more intuitive, efficient, and easier to adopt. So an example I love is the S3 bucket module on the Terraform registry, right? Like we use buckets all the time. We think of them all the time. We make them for all sorts of things. AWS recently made it where you can have 1 million buckets per account. Like we're making buckets everywhere. And this concept that is so vague and boring. It's a bucket. We put some stuff in it, but it's actually one of the most complicated resources in AWS to configure. And so when you look at that AWS S3 module that has 110 variables, giving that to a developer who's never used Terraform and may not know the ins and outs of S3, that can be pretty overwhelming. A lot of those variables are conflicting. You can't use one with the other. Some of them don't make sense to use without the other. And when you start to think about how your developers are going to be using buckets inside of your organization, you can start to scope them down to maybe smaller concepts that are easier for them to understand. So maybe something like a logging module with 10 variables, or an app assets module where you're storing things like videos and user avatars, which is kind of what we're going to be doing today. Or even doing something like ETL modules to model out the different stages of data moving through S3 buckets in your ML pipelines. And so this approach aligns with the 80-20 rule. What we're trying to do is focus our modules. Is this going to be published on YouTube? It will be published on YouTube as well. Yeah. So we'll have the workshop on GitHub and we'll have the YouTube video as well. It'll go up about an hour after the session. And then we'll send it out the whole list. So this approach aligns with the 80-20 rule. What we're trying to do is focus your modules on 80% of the common cases in your orgs that your teammates are going to encounter in their day-to-day. And one of the keys here is going back to that 20% of engineers that have experience with infrastructure as code, looking at some of these same surveys, looking at operational experience over the past few years. Industry-wide operational experience is going down because we're making more engineers coming out of boot camps, right? So we're creating this huge gap between dev and ops again, like we had 15 years ago, except for the gap now is in experience. We have very few engineers that understand how to use the cloud, but a lot of engineers that need to run on the cloud. And so by focusing on this 80-20 rule, it frees you up to have dedicated operations attention on the 20% of the use cases that don't fit into these common molds in your organization. And the principle is not just about simplicity. It's about enabling these teams to move faster while staying compliant and secure, right? We don't want developers to have to open a service now ticket to ask us something, or to start using a module and then ping you in Slack for you to look at a PR to help them figure out what instance type to pick for a database, right? We want to speak to them in terms that they understand and encode a lot of our operational expertise into these modules so they can just get going really quickly without having to ask us questions constantly. So the S3 module that we see on the left, again, that makes for some very sad developers. Nobody's ever seen that module and been very excited about their day. Breaking them down talks in their language. It makes it a lot easier for them to adopt. It makes them happy because they get right back from configuring infrastructure to developing software. So let me just check my Slack real quick, make sure I don't have anybody telling me that my audio is off or that I'm not sharing my screen. It looks like I am good. That's a very common thing for me. So why does use case oriented design work so well? So first, it keeps modules focused. Instead of trying to do much, UCOD ensures modules are smaller, scoped purpose. A focused module is not only easier to use, it's easier to maintain, right? We understand the purpose of that module. We understand how the users are going to be using that module, and we can start to think about how that module and those resources work within our organization, right? It makes a lot less major version breaking changes because the concept of logging isn't changing that much within our organization, whereas maybe a module that we designed around S3 in general might, as we have a bunch of different teams having different constraints and needs. Second, this approach makes iteration simpler. When you know exactly what the module is supposed to do, you can refine it over time without worrying about breaking unrelated functionality. Your team can confidently enhance and improve without creating chaos. And third, it's incredibly developer friendly. Developers don't want to wade through endless configuration options. They want clear, intuitive interfaces that help them get their work done efficiently. And if you think about, going to something like your GitHub main page for your organization, and you're trying to find what Terraform module to even use for, let's say, Postgres, right? You brew installed Postgres locally, or a developer did at least, right? Or they Docker ran Postgres locally. And now they want to run Postgres in the cloud for a new service that they're working on, but they don't know that AWS calls it RDS, right? So they don't even find your module, right? And so by building these modules that are more focused on what your operational organization supports in the cloud, it also enhances that discoverability. It balances flexibility and guardrails and empowers those developers to have that self-service for their common workflows while ensuring that your ops team has maintained those critical organizational standards. You're optimizing for that 80-20 rule again. Most of your team's needs are met with this minimal friction, and all these edge cases don't consume unnecessary resources. With UCOD, you're building systems that abstract complexity, standardize best practices, and align with organizational goals without overwhelming people who are trying to use them. So the 7 practices we're going to go through today are embedded logic, and we won't really do a lab on this. This just kind of sets the foundation for a lot of the other principles. We'll get into these in just a second. We'll talk about operational abstractions, survey-based inputs, use case presets, derived naming and tags, IAM policies as outputs, and then schema-driven validation. And we'll also show one of our open source tools that we use to manage this 7th item here. Okay, so what I want to do is just give you a quick view of how MassDriver works. So this is about the extent of the demo today. It's just a little GIF that's going to loop while I say a couple of things, and then we'll move on. Let me go ahead and slap play here. So at MassDriver, we've seen how transformative this approach can work. We have dozens of companies that are using these policies and these practices to enable self-service within their organizations. MassDriver itself enables your devs to manage cloud infrastructure through simple diagrams powered by IaC. And this IaC is written by your operations team. So what ends up happening, as you saw here, is devs get clickops, but they get it with version control, reproducibility, and policy enforcement. So what's really nice is in that little video right there, in just a matter of seconds, the developer was able to find DynamoDB, toss it into their architecture. You can see that it's enforcing a naming convention, and they can go in there, deploy. They're grabbing a preset, which we'll talk about here in just a couple of minutes, and boom, hit deploy. They didn't have to hunt through GitHub for 10 minutes trying to find the module, make a main TF in their app to reference it, copy a CI/CD pipeline to run checkoff or OPA or infracost, et cetera, et cetera. They literally just drag the thing onto their canvas, and MassDriver, along with your operations team, is able to build out ephemeral CI/CD pipelines for running all of your IaC policies. So devs get that ClickOps, and operations gets all of their policy enforcement with living documentation that kind of helps them understand what devs are building. And you already do a lot of this today. You draw it on a whiteboard, you draw it in lucid charts, and both of them are lies. With MassDriver, you at least get a source of truth as a diagram. So let me figure out how to move past this video. There we go. Let's move on to the next part. So this is one of our customers that has seen great success with MassDriver in reducing the amount of time they use to manage their infrastructure as code. We've helped countless teams scale their IaC adoption by making this easier to manage and self-service more accessible for their developers. By focusing on these principles in UCOD and focusing on convention over configuration, we've enabled a ton of teams to save a bunch of onboarding time, enforce standards, and move faster. And you can see these same kind of benefits using these policies and practices without necessarily using something like MassDriver. You can build this into your current workflows, or you can come and check us out. And we love MassDriver so much that we actually built MassDriver in MassDriver. So this is our provisioning engine that runs all of our Terraform, OpenTofu, Bicep, CloudFormation, etc., running inside of MassDriver. So we actually use the UI to manage our own infrastructure. So that was about it for what I'm going to talk about for MassDriver today. Let's get into some nerd stuff. So the first thing I'll talk about is embedded logic. And so with embedded logic, this is, as I mentioned earlier, this is kind of foundational to the entire principle of UDOC. And embedded logic or locals in Terraform and OpenTofu has existed for a while, but it's one of those things that I really don't see people abusing enough. And you know, a lot of times it's kind of seen as a great way to like set a variable or like rename a variable, but using a lot of the functionality that exists in OpenTofu and Terraform, you can actually do some pretty complex expressions with, you know, for loops, the different enum functions, etc. And so you can actually program a lot of what you know about this use case right into your module, right? It's hard to do this with something as vague as an S3 bucket or something as vague as all of RDS. But when you start talking about things like, oh, this is a module for running Postgres on AWS, happens to be RDS, now I can start to package a lot of what I know about running Postgres right into the module. Things like knowing the size of the database and the expected growth. Those are the questions that I'm asking an engineer when they're asking me what instance size to use. And if I can take those same questions that I'm thinking as I'm talking to them, and the answers that they're giving me, and I can write that in code, I can just let them put in variables that make sense to them. How much data do they have and what expected volume growth do they have? And boom, it picks the instance size for them. And so embedded logic is really just taking the locals in Terraform and OpenTofu and just putting as much of your operational expertise in there as possible, so that you have a centralized place of where your rules lie for how your business decides what attributes you're going to be assigning to different cloud resources. So this little screenshot right here, you know, without embedded logic, you really end up in this place that I refer to as anemic abstractions. And you see this a lot in the open source modules for Terraform on the Terraform provider registry. What you get is you have 100 organizations, 200 organizations, all trying to agree on a variable interface for something like RDS or S3. And when everybody has concerns about how it should look, what you end up with is a bunch of variables that just route directly to an attribute on a resource, right? So it becomes this anemic abstraction. It doesn't really do anything. There's no value to it. It's just a rewrite of the underlying provider. And so this screenshot over here is actually from one of our modules that we worked on with a customer that automatically, they do a lot of stuff with OpenSearch. And what this lets them do is not think about the actual master node sizes. So there's certain rules for like when you should pick a different size node for OpenSearch, and this lets them automatically get the correct node size based off of the number of instances they're running in a given cluster, right? And so for now, as a developer, it's a lot easier for me. I don't have to go look up a bunch of instance sizes. I don't have to figure out that there's different sizes that make sense for different instance counts or whatnot. And I can kind of just put in my requirements and the module is going to pick the right attributes for me. And so the way that these work is you essentially have variables like you generally do in OpenTofu. And then your locals, we use all the different functions and like iteration tools that are built into Terraform to essentially derive configurations. And, you know, this is something that I'm personally not afraid of, right? I'm a software developer at heart. It's what I do. I expect to see code. right? And we don't see that a lot in Terraform modules. We pop in there, we see these anemic abstractions. So I'm excited personally when I see a module that is complicated. It shows me that somebody put some thought and some effort into encoding their operational expertise. And so when I see something that has maybe 200 lines and some locals, I know that there's some expertise in there. And I feel like we have this like zeitgeist almost in operations where it's like, oh, we don't want to build a complicated module. It's not complicated, it's complex. The interface is simple, right? Like that's the goal there. And developers are used to working with abstractions. Hell, most of them do, right? They use passes every day. There are already abstractions over the cloud. Why can't our organizations design these same simplified interfaces that give developers what they need without making them an operations engineer? The real beauty of this approach, right? So this is just a real simple contrived example here. We might ask for something like, what is the expected throughput of your database, right? Probably a few more questions there for RDS. If I got any DBAs in the room, we're probably talking about data volume growth, base size, read versus write workloads, right? Things that developers know, things that they are thinking about with their services, things that they're doing in their capacity planning, query optimization, right? So talking to them in that language and then picking this D5, M5 large based on those inputs. And what's really funny about this is when you aren't doing this, I don't know how many times I've been in AWS and I've seen something like DB R5 double XL. And I'm like, things got 1% CPU utilization. Why is the instance this big? And the answer is nobody knows. You find the module that made it, and it's literally somebody just typed in that value. And the answer for any seasoned ops engineer in the room, we all know the answer. The developer probably over provisioned it, right? They didn't know what size to pick. They think, yeah, I got a big application. I need an extra large database, and boom, that's the value they put in. Or they looked up some stuff online. They hopped onto some docs about the different RAM and CPU sizes in an RDS instance, and they picked one that felt right. What's really awesome about some of the practices we're going to see here with operational abstractions and these survey-based inputs is your Terraform and OpenTofu modules become documentation for what the developer is expecting to do, right? So now I know why they have a DB M5 large. I can look at their expected throughput, the base data size, the expected volume growth of that database, and I know why it calculated this DB M5 large. So that's the other really cool side effect is this is your variable inputs start to become documentation rather than just some configuration that's a snapshot from some point in time. So this is here is for people that aren't in the actual session. We're going to hop over and we're going to do just a little, actually, sorry, one second. Okay, sorry about that. So we're not going to look at much for embedded logic because we're going to kind of see this throughout the rest of the examples. But kind of going back to this concept again right here really quick. This is what we're aiming for in these modules. Maybe not something as complicated as this, but something that kind of imbues our expertise into this module. And so some of the key takeaways here is, again, we're trying to centralize our operational expertise into these locals. We don't want to make just thin wrappers around cloud APIs. We want to use this embedded logic to automate decisions based on higher level inputs that make sense to developers. We're going to see a couple different ways of designing those in just a second. And this helps us with consistency, right? This is another thing that's pretty interesting is two developers ping two different ops people asking them, hey, what size database should I use? Do you think you get two different answers? You probably do, right? Maybe you get the same one, but now like your data, your documentation is in a Slack conversation between two people versus what you put into this and what your team decided on the logic of how to pick one of these maybe instance sizes or whatnot. And then finally, it simplifies IaC, so developers are able to get what they need while making sure that you have these organizational standards in place. So the first thing we're going to look at is operational abstractions. And these first two concepts that we're going to see are actually fairly similar technically, but conceptually different, right? So when we see the code and we start working through them, they're going to feel very similar. But the big difference is operational abstractions are the things that the operations teams care about are non-negotiables. These are high-level inputs that encode the organization's operational standards. These inputs allow developers to focus on their workloads that have to worry about underlying details, right? For example, you might use an input like resiliency or availability or SLA, right? These are words that a developer knows, and we can use these inputs to derive what configuration, right? So, maybe this SLA here isn't literally, a float or a double. Maybe it's some sort of enum. Maybe we've got 3 or 4 different classes of SLA that we guarantee for all of our microservices. And so if I'm a developer coming in and I'm working on the checkout application, I need a new database. I can say, hey, the SLA for my application is 4 nines, right? And I don't have to go and figure out multi-AZ. I don't have to go figure out backup schedules. I don't have to figure out replicas and replication. I can simply say, hey, this is the uptime that my application expects. And then us as the people that are designing maybe the Postgres module can say, hey, okay, this is how we can help guarantee this SLA, right? And so now what's cool is developers are able to set complicated configurations, complex infrastructure based off of something they actually know. And we've created consistency in this very scoped use case of a module that reacts to these different values that they're putting in. This module is now starting to give us documentation. I know what the SLA is of this service. It's right there in the Terraform values that is helping me figure out how many zones to pick, how many replicas to pick, and how often I'm taking backups. This approach removes the need for developers to learn all these specifics of these cloud services while ensuring that all the configurations align with your operational policies, right? This is another place that is kind of scary for, I think, a lot of operations engineers that are looking at self-service, right? You're like, if I give developers Terraform and a key that can create anything, they're going to create anything, right? And that is an operational burden and a maintenance burden for you, right? And so how can we give them that flexibility without increasing our workload? Just a little bit more on operational abstractions. So, for example, if we go back to this SLA, right? This module starts with a high-level input like an SLA or resiliency. Internally, it's going to use, a couple of these attributes maybe together to figure out what zones we need for a database, or if replication is enabled, or if we need frequent backups. It's going to shield these developers from having to learn all this stuff, right? And so, again, one thing I think is really key here when we're talking about convention over configuration is these conventions are your organization's conventions. This isn't me telling you you should have an SLA field that supports 3 enums, or you should have a resiliency field that has 3 different enums of small or low, medium, and high. These are conversations for your operation teams to discuss as you're designing these modules, to think, okay, what do we care about? What does compliance say we need to do? Like, what does our SRE team need for this thing to stay up? And then codifying those decisions into these abstractions that make sense to developers, right? The convention and convention over configuration in IaC is all about the conventions of your organization, not the conventions that I'm telling you or that an open source project is telling you. These are the conventions of your business. So as we see these different examples today, that's just really key to think about. You might see one when we start here in just a second on the code and be like, that's not what I would do. That's fine. The idea is to just get the concepts down and then go back to your teams and say, okay, how do we take what we know and create the right abstractions for developers so they can move quick in this 80% use case and not create more work for us? So what we'll go ahead and do is we're going to hop over to this base example, and we're just going to start on our first operational abstraction. So let me go ahead and pop over to the code. And look at that, I had a little note here to start my timer. I'm going to go ahead and clear that. I started it. Sorry, I got to hit that espresso. So what we're looking at here is a very anemic module. And so I went and took an old version of an S3 module and kind of brought it in here. And so we'll look at the main code for a second, and then we'll kind of refactor this from here. But without picking on public registry modules too much, like, who's seen this before, right? Like, every single attribute of every single resource is a variable, right? And this is very common in the open source space in Terraform modules, seeing this just passing the variables through, right? And there is value to this module. I just say there's not much value, right? Like, I honestly look at the Terraform registry and the modules there pretty frequently to get an idea of all the related resources, right? I think that's the actual value here, is hopping over there and saying, hey, what do people need resource-wise, all the different resources they know to make a Postgres, right? But taking the actual module and wrapping it in another module, that module is a useless abstraction that is going to tie you to the maintenance of that public module, right? Somebody wants a new attribute added that wasn't exposed. You have to fork the thing and then try to get it back into upstream, right? Versus just changing your own module. When I see modules like this, I'm just using them as references. I don't want to take on the maintenance burden of trying to synchronize with some external team and get my team's opinions pushed through on a public module. So we're going to take this module and we're going to refactor it a bit. So what we're going to do is, if you're following along and you have that Git repo open, if you scroll down, you'll see that there's a lab. I'll go ahead and share it here really quick. Right down here on the README, you'll see that there's a lab 1. And so what we're going to do is we're going to kind of walk through this process of building this first operational abstraction. So there's a couple that we're going to do here. One is we're just going to hard code force destroy to false, false, right? We don't want anybody to ever accidentally delete a bucket full of data, right? That is maybe one of the operational. And again, this is us making up a fake business and talking through the conventions and things that make sense for our business. I would do the same with your operations team as you're working through these different practices. But for our fake business here, what we're going to say is we don't want anybody to ever delete a bucket unless they've actually cleared it out of resources. We don't want anybody to accidentally delete a bucket. So we're just going to hard code that to false. That is one of our operational abstractions. We're just going to hide that from you completely. We're not going to show you that variable. We're not going to give you the option to use a foot gun. So just checking for questions over here. Okay. The second thing we're going to do is we're going to say retention policies are mandatory, and we're going to make a couple of them by default, right? Anybody who's worked with S3 retention policies know that they can be a bit heady. If you give somebody access to write them, people will make crazy ones. And so what we're going to do is we're going to say, hey, we've got a handful of pre-designed policies that developers can access when they're making this or using this module, that they can just pick from by name, right? Now, again, 80-20. If you have a developer who comes along and they're like, hey, this doesn't work for me, that is a great thing to hear, because what you're hearing is you're getting feedback, right? Just like on a product. And that's how we need to be thinking of these modules. They are our products as operations engineers. I want the phrase MVM, minimal viable module, to be a word that we actually use, right? We want to ship something and then get feedback on it, right? That is the collaboration of dev and ops. And you put them together, maybe you get DevOps, maybe you don't. But so we want to hear that from a developer. We want them to say, hey, this doesn't work for me. And you can start incorporating that feedback. Maybe it's adding some other retention policies that make sense for the organization. Maybe that's a conversation for the ops team to have, right? Or maybe this developer's in the 20%, right? And this is great because your other 80% of your developers are doing this on their own. And now you have dedicated time to work with this engineer to figure out what is the right module designed for them, maybe for a module that they wholly own. The other thing we're going to do is we're going to just hard code all the access control defaults to private. For these buckets, we don't want anything to ever be public. And if a developer needs something in this application asset bucket that we're designing to be public, then they can attach it to our CDN module, right? Which will also have like our CDN conventions in it. So this one's pretty straightforward. It's going to be simple on purpose. Kind of looking at that open search example earlier, I didn't want to lose anybody in this workshop on like diving deep into, Elasticsearch fundamentals or Postgres fundamentals or multi-zones and replications. I wanted the examples to be rich, like almost trivial, so that we could think about how they work and not think about what they actually are. So with that, we'll go ahead and get started. So looking at this module here, so as I mentioned earlier, I just want to hard code this. I want this to just be force destroy false. We don't need this. I don't want anybody to foot gun themselves. I'm fine with that. So I'll just kind of come over here. I'm going to yank this out. I'm happy about that. Looking through these different, sorry, let me just got too many things open here. There we go. Looking through these public access blocks, right? There's a bunch of things we probably don't want people to expose, right? So right now, again, this is an anemic module. We're just letting them set whatever they want, but we're saying for our application assets module, we don't want them to ever be exposed to the public without a CDN. So we're just going to go ahead and block everything, right? That's great. We're lowering this variable interface, right? We're making decisions for this 80% of our organization, and we're making it easy for them to use it by taking away options that they don't need to set. This is great. We like this. It makes things easier for people, right? And we got to just always keep that 80-20 in the back of our head. It's fine if somebody is not happy with it. We'll have more time to deal with them and work with them if 80% of people are happy with what they've got. And this is one of my favorite beasts. So we'll bring in versioning status here in a second as well. That's definitely something we want to. That's definitely something we want to set. But this right here is one of my favorite anemic abstractions that I've come across, and this is in so many of the public modules where there's literally just this extremely complex iteration happening over just nested sets of objects where you're quite literally just mimicking the resource interface as a variable, right? And so like that is a lot of code. That is a lot of code right there, right? Like this general pushback that we kind of see, this objection of like, oh, we don't want to make our modules complicated. That's complicated right there. That's super complicated. And what does it do? Nothing. Doesn't do anything, right? It's completely up to you to put in the right input. Sorry, I got like 10 screens here. So you guys are over here, code's over here. So we want to make this just go away, right? We want to come up with some basic rules that we are going to use. And so if we kind of, if you have that, I've got my my GitHub open on another screen. If you open that up, we can kind of go through and start to model some of these policies that we want to have. And so what I'm going to do is I'm going to come back to my main file here. We go up to the top, I'm going to do some locals. And so what I'm going to do is I'm going to first just add, we're going to add a, okay, what everybody's going to be able to see today is that I code in cursor a lot, and I don't really type anymore. I start to think and then just tab complete all the way through my life. And I'm not using cursor right now because I was trying not to do that. So you're going to see me hit tab a lot of times and nothing happened. So we want to come up with a handful of policies here. I think we're going to do maybe we'll just do 4. We'll do an ephemeral policy. Leave that blank for now. We'll do a short-term policy. And again, this is all in that GitHub README. An archival policy and a permanent policy. And so what we're actually going to do here, again, you can do a lot of wild stuff with locals and the programming blocks that we have in Terraform and OpenTofu. But in this example here, what we're going to do is we're essentially just going to pick a couple of the attributes for developers, right? We're essentially just going to kind of map this here. We're going to say ephemeral, deletes records after 7 days. It's just truly like an ephemeral storage that they can use as a bucket. They need to store some stuff. They don't need it around a long time. They don't need interesting storage classes or transitions between storage classes. I just need to put something in a bucket for right now. I'm going to work with it, and I want it to go away in a couple of days. I don't really care when. And so what we'll do is I'll just go ahead and add new expiration days equals 7. So we have in our README transition days. It's not going to be any, and storage class is also not going to be anything. Right. And so now we have this idea of a retention policy, and we'll fill out these other ones here in a second. I like to just go ahead and do one of them just so I can get my code straightened out, and then we can kind of fill in the rest of the variables here in a second. But what I want to do now is I want to come back down to this lifecycle configuration here. and kind of update it for using this structure that we have, right? And so what I want to do is before we actually do that part, I want to hop over to the variable interface and think about like how a developer is actually going to pick this retention policy. So if we come over here now, we've got these big bag of these lifecycle rules that any developer is probably going to spend an hour and a half reading through how they work the first time, set it up, and then 2 months from now, and they need to make a bucket again. Guess what they're going to do? They didn't memorize that from a month ago. They're going to read it all again. So what we're going to do is we're just going to get rid of that. And we're going to add a variable called retention policy. And so the retention policy will be a description. This will be define how long objects are retained in the bucket. And now we'll keep the description short here just so we don't get into it. But like descriptions are your documentation besides the types that you expose. So in a situation like this, I might put more of like a multi-line doc or something like that, kind of trying to describe this concept to a developer. So when they run Terraform docs, they get a really good description of like what the retention policy is going to do. But anyways, we're just going to leave it kind of short here just because nobody wants to see me type a bunch of paragraphs. We'll say we want to keep developers safe. So we'll go ahead and say that the default storage is permanent. So that's effectively we're going to do no tiering. So ops teams decided no expiration, no tiering transitions, just stores everything in the S3 bucket, like a 2007 S3 bucket. And then we can also add some validation here as well, right? So we know, looking at this, that we only have about 4 different policies that we want to support. And so rather than a developer typing in something crazy and it just blowing up when it goes to run, we can add validation here. So I'll say condition equals contains ephemeral, short-term. Man, I don't know how to spell anymore. That's the problem with AI. I just don't know how to spell. I'll pull this over here real quick. I'm going to copy and paste these. Archival and permanent. Nope. Can't even spell permanent. Nice. This will be message. Yeah, I'll just go ahead and do there we go. So now we've defined a retention policy as an input, right? So now what we're giving developers an enum. We're giving them a set of options to pick from, and we're going to pick the configuration based off of one of these classes of retention policy the operations team has decided that 80% of our buckets are going to fall into, right? So now a developer is going to set retention policy equals to permanent or ephemeral, et cetera. And now we can kind of back out the rest of these values that we have here. So instead of making everybody watch me type all of these, I'm just going to go ahead and grab the other 3 from the labs that I already committed to get. You can kind of just see the rules that our operations team has come up with. They say our ephemeral policy is all, the records expire in 7 days. There is no transition. There is no storage class. They just delete. Short-term storage will expire in about 30 days. So it's very similar to ephemeral. Maybe this is where we're, storing, just some jobs of some data that we need to work on, right? Maybe short-term is something great that we're going to use across all of our buckets. And maybe it's something we'll use in like a staging bucket for an ETL pipeline, right? We don't want to store that data in there forever. Archival is like, hey, I got something that my application needs to store and I need to keep it forever, but I don't need it to be hot. I can just go into cold storage in S3. And then we have permanent, which is going to have just sitting there on AWS's standard tier for S3. So now we have these idea of these policies by name. And now what we can do is we can come down to our lifecycle configuration here. And instead of having this dynamic block that's literally just interpolating every single thing from our variables, we can kind of come in here and we can fine tune this to have just the 2 rules that our team cares about. So we'll go ahead and add the first rule. which will do our object expiration. And I'll just kind of copy and paste this and talk through it here. So this is going to check our lifecycle rules if it has expiration days. And if so, it's going to enable this, this status here to expire, and then it's going to set the days for this to expire. And then the other one that we're going to have is that transition class. So we'll add a second rule for that. This one's a little more complicated in the way you have to express it because it may or may not be there. But this one's effectively going to set the transition as 3 buckets to transition through these different stages over time. So right now, the only one we have is archive. After a day, it just moves it to cold storage, right? So we write the record, moves to cold storage almost immediately. We can add others in here if we want. Maybe we this application assets bucket. Maybe right now we're just using it for avatars, but in 2 months we add a feed kind of feature, right, where people can post pictures and we're scrolling through it, right? And so recently accessed data needs to be hot and on there all the time, but maybe data or files that were uploaded 30 days ago aren't viewed as much, right? And we want to do some intelligent tiering, right? We might add, an additional retention policy here that prioritizes newer data and then is cost efficient for older data, right? So we can add additional policies here. It's very easy, right? Engineers come along and they need another policy. Does this make sense for the 80% use case? If so, bam, we add it. If not, we figure out how to build them a module that makes sense for their team. So now what we have is and actually, I didn't mean to include this versioning in here. This was a part of another workshop, a later part of the workshop. So I'm just going to pull that out for now. I'll put this versioning status out since it wasn't part of this one. So now we've got, a pretty basic operational abstraction. That was us saying, hey, the operations team has rules around how retention policies work. Instead of making you understand lifecycle configurations, expirations, transitions, the different storage classes, we just say, hey, these are the 4 that we support. We can add other retention policies if they make sense for the 80% use case. And if not, we're happy to help you guys design a module and figure out the right configuration now that we have all this free time from not having to serve the 80% of the team. So now I should be able to come over here and do tofu. Let me just do tofu init and tofu validate. I don't know if I initialized this one yet. Okie doke. And then undeclared local variable. What did I miss here? Lifecycle rules has I didn't capture it. So what I did here was these define my rules, and then I want to pick the actual rule that I want. So I'm going to say lifecycle rules equals local.retention policy policies. There we go. Sweet. And so now what we have is we have less code, more operational expertise, less choice for the developer, right? And I think that is the trade-off we're looking for, is what is the right trade-off between not having choice and being able to move quickly. And so I feel pretty good about this lab 1 kind of going through these operational abstractions. So other ones that we might see here, again, we might see them on something like an SLA. We might see resiliency, pretty much anything where your operations team is very concerned with those configurations, but developers don't necessarily know the terms and how it works in the cloud. I think those are good candidates for operational abstractions. And I think one of the key things here, it's a little harder to kind of grok with S3. It is a weird object, but it's very transparent when you start looking at databases that a portion of the cloud API is very ops-centric and a portion is very dev-centric, right? So like, let's look at Postgres or MySQL or anything running on RDS. Again, replicate counts, zone distribution, backup frequency. These are very operational, reliability-oriented attributes, right? But then there's things that the developer cares about, right? I brew installed Postgres. I know that I've got a particular type of workload, so I've got to set some stuff in a parameter group. Like these are things that I know. I use Postgres all the time, but I don't use RDS, right? These are the things that I care about. I get Postgres, I know the version, and I'm able to control maybe some parameter groups, right? That's what I want to see. But the thing that kind of sucks about the cloud is all these attributes are mashed into one HTTP call, right? And unfortunately, that HTTP call is on the other side of a Terraform module for many orgs, right? So we don't both want to literally be committing on the TF vars. I don't want to fill in 3 fields and then ping ops to fill in the other 7, right? You don't want me to guess at the other 7. So how do we get the experience that I'm looking for as a developer without becoming an operations engineer? And that's leading into these operational abstractions, hiding this stuff from me. So next thing we'll talk about here, let me just check for questions really quick. Ephemeral. Yeah. Like not very, very temporary. We could call it temporary. Sorry, I just saw that question. Just ephemeral-ish. Like it's from my app's point of view, I don't need it around very long. We could even say that maybe ephemeral was a day. It would just be up to our team to kind of determine what these different retention policies are. So the next concept is survey-based inputs. And the really funny thing about this is another thing that every operations engineer is already doing. Everybody's doing this right now. And you do it in a couple different places. You do it in ServiceNow. You do it in ServiceNow. You do it in pull requests. You do it in Slack. You do it by the water cooler, right? A developer comes up to you and says, hey, I need help setting up a new cloud resource. I'm making a Postgres database. What instance size do I use? Well, I'll tell you what, if I'm just sipping a coffee one day, hanging out in the lunchroom, and somebody goes, hey, what instance size do you use? Guess what I don't do? I don't just say an instance size. I start asking them questions about their workload, asking questions that they probably know the answers to, or they should know the answers to, right? And based off of the questions that I'm asking them, I'm building a mental model of what that infrastructure should look like. I'm asking you things for a Postgres of, hey, like how many transactions per second do you expect? What is the read versus write expectations of this app? How much data are we starting in this database, and how much do we expect it to grow, right? This is helping me figure out IOPS. This is helping me figure out storage. This is helping me figure out replicas, right? I'm not asking the developer to turn around and saying, how many replicas do you need? They don't know. You don't know. Nobody knows until you understand the characteristics of the workload, right? And that is what these survey-based inputs are about, is getting an understanding of the characteristics of the workload, but encoding those questions that you would ask as variables. And then taking the mental model that I'm building, or that my other ops partner is building, or somebody on the SRE team is building in their mind, and actually collaborating as an ops team and say, okay, well, I know RDS, Chauncey over here absolutely knows a Postgres. He's a DBA. Like, let's work together to figure out the right abstraction so developers can get databases quickly whenever they need them without tapping either of us, right? Like, that's what we're trying to do. What do we ask developers? What do they tell us? And how does that inform the decisions that we would make when we give them advice on what to pick? And that's what survey-based inputs are about. So again, this is a very basic contrived example. You probably need a little more than expected transactions per second, but just to kind of make the idea easy to grok, if this was it, transactions per second, if that was all that would matter, this might help us determine instance size, IOPS, storage, etc. Right? So we have an idea of this. Maybe it's even helping us figure out like the number of replicas, right? Or when to turn on auto scaling, right? And so just kind of backing out those things that you talk to your developer customers about as an operations engineer into inputs, right? Don't ask them all these questions. Take that knowledge and toss it into the ether, and then tell them a DB M5 large, right? Now their workload requirements and characteristics are documentation. They're right there in the Git repo. They describe how they expect their application to work. They have described how they think the characteristics of their database are, right? And those are going to change over time, and that's fine. But you at least understand how you got to the configuration that you have instead of just having a configuration. Oh, I had a typo. Okay. Thank you. Hey, open a pull request for me to fix that typo. Can't believe Cursor didn't catch a. Oh, that's right. I'm not in Cursor. I'm in freaking VS Code. Okay, so survey-based inputs. So again, we're trying to translate these things that developers understand into the operational configs that we want. So kind of looking at this a little more, like a developer might know the data growth rate, or it might say that it's a moderate growth rate, right? And they're expecting 2,000 transactions per second, right? So we're very similar to operational abstractions. We're taking these inputs, we're running them through some locals that help us figure out the right configuration. And then what we'll do is usually maybe output that at the end, right? Let them know the instance size that they got. It's important for them to kind of start to learn some of this stuff, understand what they're running, right? Now they understand like how they got to an M5. It's not us talking and we just say, at M5, enjoy it, right? Like they can see, okay, these are the decisions that were made by the locals, and this is the instance type that was set, and this is the instance type that maybe is in my outputs. Sorry, a little brain fart there. So when you're working on these, one thing that does start to become interesting in some cases is you'll actually see places where your survey-based inputs may augment your operational abstractions, right? So you might have an idea of, hey, like our base zones that we do is we always do 2 zones or something. Maybe we always do 3 zones, whatever, right? But maybe there's something about the characteristic of the database that requires an additional zone. Maybe we have too many replicas in 2 zones, right? And so you can actually kind of dovetail these 2 concepts together. And like we saw that retention policies earlier, maybe something about this application assets buckets, like workload characteristics, makes me change how the tiering works, right? So if I'm saying that maybe I am moving to a point where I have this feed idea, right? And so when I say, hey, I'm gonna have this feed, like this is the type of data access pattern that I'm gonna have for this bucket, that actually informs how I transition objects through the different tiering of S3, right? So these are 2 very distinct ideas that have similar functionality and how they're implemented. It can be easy to conflate them. Again, the key thing is the operational abstractions, what the operations team talks about and cares about kind of on their own. The survey-based things are the kind of questions that you would have with your operations engineers. But they can actually interact on these locals and enhance each other, right? So don't be afraid of kind of using them to their full advantage. So let's go ahead and work through our first survey-based input. So if you go back to the lab, and I'll pop this up over here, you'll see that the second lab here is just focusing on the versioning. So this is the thing that came in a little earlier from the last one. And so, we're writing our application's writing files to this bucket. We've already determined that there's some sort of retention policy that the organization wants to support just to, maximize our cost savings on S3. Minimize data that we're just kind of keeping around forever. But applications have a workload characteristic. They might actually care about versions, right? Like let's say that we're building some sort of Notion competitor and we want to keep every single version of a doc that's been edited, right? That's really important for our application. I need to keep every single version of it ever, right? Or maybe this part of the doc is storing invoices, and for auditing reasons we keep them for a year but we don't need them afterwards, right? Like there's different characteristics for how my application is going to behave with this, not just how what the retention policy is of the data overall, right? I have this versioning that I care about. And so what we're going to do here is just model some versioning policies for developers as well. And so what we'll go ahead and do is we're going to start with that, and then the next part of this will also get into doing notifications as well. So we'll just start with the versioning part. We'll get to the notifications here in a second. Okie doke. So I'm going to switch back to this module. So we've already added an operational abstraction for our retention policies. And now we're going to focus on these workload characteristics, right? So these are questions that I'd be asking of developers, like, hey, I need an S3 bucket. I'm going to be storing some files. And it's like, oh, well, do the files change? right? Like you might have files that don't change, or you might need files not to change, right? Like this is an interesting conversation, right, that we're going to be having with this developer. Do the files change, or do they need to not change, right? I might need have some compliance or governance requirements that says a file cannot change, right? So developers like, yeah, you know, we're going to be changing these files. Like, oh, what happens when it changes? It's the user's avatar. It's like, oh, well, it doesn't matter. Like if somebody uploads a new avatar, it replaces the old one. Great. Do we need to keep the old one? Nah, we don't do undos for avatars, but we do undos for docs, right? Or right. So there's different characteristics of how the application is going to work with this bucket. And that's kind of where these survey-based inputs kick in, is how is the application going to work with this thing, not how is it going to work under the hood. So let's go ahead and start working through this next one. Let me just check for queues. Okie dokie. So the first thing we're going to do is we want to add some versioning. So I deleted this resource earlier because I accidentally left it in the base example, but we'll come back over here and we want to add versioning as an option here. So I'm using for anybody who's AWS, like super familiar with AWS, I'm using AWS v5, where they break out all the different S3 attributes into different resources. So I'm going to use the resource AWS S3 bucket versioning. I pretty much just call all my variables this or main until I come across one that is the same resource type but with a distinct difference. Then I will give it a different name, but I just kind of call everything this by default. The bucket that we're going to use here is our main S3 bucket. I think we give it the ID, if I recall correctly. Okay, cool. And then versioning configuration is status. We'll just say enabled for now. So we're gonna say enabled for now. We're gonna back this out into some versioning rules. So if you look back at this doc, you'll see here that, you know, the 80% use case that we've decided for our organization is we're going to have 3 different rules or versioning policies for developers to pick from, right? We don't want them to get lost in a million different configuration options. We say, hey, here's 3. If these don't work for you, let us know. We can add another policy if it makes sense for the 80% use case. If not, hey, let's fork it and your team can own it because you're gurus and you're that 20%. So we have 3 versioning policies here. We got none, so no versioning applied. If we update a file, like something like an avatar, it just replaces it. We have persistent, keep all versions indefinitely. And then we have like an audit versioning policy where we keep them for about a year, right? So very similar to retention policies. I'm going to come in here and I'm going to add versioning policies. I'll do none, persistent, audit. And then what we saw was that there's effectively two attributes that we're going to be controlling with this. One is going to be whether or not it's enabled. So it's going to be false. Retention days is null. So when you set the versioning to none, you're not going to get any version. We're not going to retain it for any days. And for persistent, it's going to be enabled true. Retention days is also going to be null, which is essentially forever. And then audit will be enabled true. Retention days 365. We keep records around for a year. That is what we do. Okay, so we got these versioning policies in here. And so what I'm going to do now is I want to take this very similar to these lifecycle rules. I'm going to pick the rule that we're going to use, right? So versioning rules equals local dot versioning policies var dot what do we want to call this? I think I'll just call it versioning policy. We don't have this as a variable yet. So now I'll come over here and I'll add this as a variable. And this is going to actually look very similar to this retention policy. Again, like these 2 practices of operational abstractions and survey-based inputs technically, like the way they're implemented, they're very, very similar. But again, the idea is who the subject is that you're talking to about how to come up with these attributes. So for the versioning policy here, what we'll go ahead and do is it's going to be very similar to this guy up here. So I'm just going to copy it because you all know I can't type. And then this is going to be controls versioning and object retention behavior. The default will be, I'm going to give developers a safe default, so we'll just make it persistent by default. And then we had 3. We had none, we had persistent, we had audit. Okay, and then the error message will be versioning policy must be one of cool. So very similar in structure. Coming back over here now, you can see that this isn't failing. I have this versioning object that I now need to add some logic for. So what I'm going to do here is just add in the ternary, so it's called local versioning rules. Suspended, right? And now we've added versioning, so I should be able to do tofu validate here. So font size looking good for everybody? Okay, sweet. I'm going to clear this real quick. So there. So now we've added versioning to our bucket in a way that respects the policies and the expected use cases of this module for our developers. So now they can come in and just say, hey, you know, I just give you this enum. This is the value that I need. I need it to be forever. Thank you, Phil. Now, one of the other abstractions we want to do here, though, is we know frequently when you add something to an S3 bucket that we need to do some sort of notifications, right? And so in AWS, there's a lot of different notification places that you can send your object events to. So I upload an object S3, it sends a notification out. Now, before we get into the services that you can notify, why do you do this, right? So let's say you have a partner, and I'm going to say a crazy word here. You'll know who's heard this one recently. FTP. Let's say you got just an old school partner. Maybe they're in healthcare. Maybe they're in some old banking thing, but they need to FTP documents to you. Right? You know, they FTP you a document, and you want to trigger maybe a Lambda, or trigger a notification to another service, or put something into an event bus, right? Or maybe it is your avatar service, and we don't know what size image people are going to upload, but we do know the size image that we're going to render on our profile page, or that we're going to make it a circle, right? And so when somebody uploads an avatar image to this bucket, we want to trigger a Lambda that does like the resizing and cropping and stuff, right? So this is an application asset bucket that we're designing, right? And so we expect that, you know, our developers are probably going to need some sort of notifications. And so as an operations team, we're going to make decisions. So we're going to say, okay, well, there's 3 places that you can send notifications to in AWS. You can send them to Lambda. If you're sending them to Lambda, fan outs, your problem. So we're going to say we're not going to support Lambda as one of the destinations. The other 2 options are EventBridge, which can be a bit heady and a bit expensive, and SNS. And so for cost optimization, which is something that our engineering org has been tasked with, CFO's mad, spending a lot of money on the cloud. We're saying that 80% use cases, when you need notifications, we'll send it out to an SNS topic, and you can tie that topic into an SQS queue or whatever the case may be. If you are in some edge case where you actually need a Lambda to process this, or you really, really need us to turn on EventBridge and start connecting it to all things AWS, you're outside the 80%, and that's fine. We have time to work with you on that now because 80% of developers are able to do this stuff on their own, right? And so what we're going to do is we're going to add events to this module and conditionally create a topic if you have an events turned on. Otherwise, we won't make this this topic. And so if I pop back over to the lab here, you can see that what we want to do is let developers essentially specify the important events of this bucket. And these are the events that's going to trigger SNS. And if they don't set any events, then we don't make an SNS topic because they don't need any events. So let's go ahead and add this SNS topic. So I'm just going to kind of pop down here to the bottom. And whenever I'm adding a resource, I always just hard code everything and then kind of back it out to variables. So I like to have a tofu that's green when I apply. Oh, I just got that. That's what you meant by the 2 green leaves. I love it. I was like, why is there 2 green leaves earlier? I just got it. You're the man. Sorry, just watching the comments over here. So what we're going to do is we're going to go ahead and add the SNS topic here. So AWS SNS topic, call it this. And there's going to be an account here, but for now, I'm just going to go ahead and set the name. And we'll get into this a bit more in section 5. But one thing that absolutely drives me wild is the pervasiveness of naming things in a module. And there are so many modules on the Terraform registry that have, I think the VPC module has like 20 different name fields. Are you kidding me? I'm trying to put stuff in production and you want me to name 20 things? This is literally the hardest problem in computer science. You just put it on me 20 times. I ain't even gotten to off by 1 errors. I'm already out. I'm checked out. I'm clicking through the AWS console. I'm not filling out 20 name fields. When I make a module, you're making something. So I think there's one thing that's key here is there's 2 real distinct types of modules. There is the Teralith, where you have 5,000 resources all packed into a thing. Well, that's technical debt is what you got there. You need to break that thing up into smaller pieces. That's really hard to have one name for all the stuff. But when you're making small use case oriented modules, it's very easy for you to have a name for the module and then derive every other name. And so we're going to talk about deriving names in just a bit, but I'm just going to do a little taste test of deriving names here. So I'm not going to let somebody specify the name for this topic. I'm just going to kind of piggyback off of the AWS S3 bucket name. Notifications. There we go. So just kind of hard code this thing in here. And then what we're going to need to do as far as sending these notifications is tie all the notification events that the developer said that they wanted, right? And so there's going to be this other object here, which is AWS S3 bucket notification. This only 1 notification. The bucket is going to be AWS S3 bucket this dot ID. I'm pretty sure it takes the ID. Yeah, I'm pretty sure it takes the ID. Well, we'll see if OpenTofu gets mad at me here in a bit. And then we're going to add a dynamic block here. We'll call it topic, or it's called topic. And then for each of these events that we're going to be taking from the developer, notify events. We'll come back to that here in a second. So if they supply any events, then we want to apologies for all the pop-ups covering everything. Topic ARN. Okay, so you can see that we're obviously missing this part on notify events. And so this one will be a pretty, I don't want to say a silly variable, but a pretty basic one. So we'll expose notify events, description, a list of S3 events to notify on. And then we can do type list string. Default is none, so we're not sending any by default. Now, you can add validation here. There's a lot of S3 events. So this is like a YMMV situation. Like, do you actually want to put in a condition that includes every single one of them? You definitely can. It's going to be an absolutely long line. So I'm just going to leave it off. But it kind of depends on your team's appetite for catching somebody typing in the wrong value. It's honestly, it'll get caught very quickly if you type in the wrong one, but it does always suck to Terraform apply something and then see it blow up in your face versus, seeing it fail during a Terraform plan. But we'll leave it blank for now, just don't have to copy in 1,000 of these. So this should all be vet now. Now I know that I need to put some IAM in here as well, but let's see what I did wrong. It does not have a count or a for each. Did I put my for each in the wrong spot? Notification. Where are we at? Unknown variable var.notify events. Did I spell it wrong? Variable notify events. S3 topic. Let me just comment this out really quick. Okay, on line 79. Let me just check here. There's no variable. There's no variable named var. Where am I? Did I type var.var someplace? Okay, let me clear this out really quick. 79. Where each var.notify events. Did I put this in the wrong file? Something? Because AWS SNS topic, this does not have count or for each. Oh my gosh. I'm so goofy. I didn't have my count up here. I see what's going on. Okay. There we go. Give ourselves a little count there that we can use. Okay. Okie doke. So I like to do this. So I know that it's common to just see that count ternary like right in there. I love code that is kind of self-documenting. I like to know that notifications are enabled. I might use this in an output. There might be some other resources that I need to conditionally turn on or off based off of this. Instead of kind of copying and pasting it over and over again, I just kind of err on the side of making it very readable, right? Instead of, a developer who's troubleshooting this the first time, seeing count equals the length of events greater than 0, then it's 1 or it's 0. Like, that's a confusing thing if you don't know the Terraformism there. So I like to kind of back it out to a local name that makes sense to people, saying, okay, well, if it's enabled, well, what does enabled mean? Okay, it's enabled if it's greater than 0. Got it. Okay, great. But now when I read this, I understand exactly what it means. I have to get a PhD and Terraform. So I think now we are good on this. We kind of nailed the two things we're trying to go for here with our survey based inputs. So the developers say, hey, there's definitely some events that we need to be triggering some notifications on. They don't have to stumble through all the stuff that I just stumbled through, despite the fact that I've been using this thing for a decade. And they get some versioning policies that are very high level and in the terms that they're using, our organization's using. So The next section, I'm going to go ahead and just double check, see if there's any questions real quick. The next section is actually pretty boring. You guys are like, the next section is boring. Geez, Corey, where have you been for the last hour and a half? So the next section is a bit boring, but I think it is an extremely valuable idea that many times I see teams kind of phoning it in on. And we call these use case presets. And you'll probably see these. I need to stand up. You'll probably see these in a lot of Terraform repos. It's the examples directory, right? You see it all the time, right? You go hunt down the RDS module from the Terraform registry. You pop open the examples to figure out how to set up MySQL. You see there's about 4,000 attributes in there. And you're like, thank God they filled them all out for me, right? Like they routed them directly to those attributes for me. They gave me all the variables, right? They're examples. Now, I like to actually call them out as use case presets for a couple of reasons. One is I think it frames your mind a bit better of like what should go in it, right? This isn't me showing you what a string looks like. Hey, what's the name? The name is foo, right? Oh, like what is the name? It's bar, right? Like, oh, there's 3 of them, right? It's me actually thinking as an ops engineer, and based off of the 80% of the engineers I've been working with that use this module, how are they using it, right? What presets, what examples can I put in here of variables that make sense to the org and aren't just something that they can look at and go, oh, I understand how to use the thing, right? Like a lot of these examples kind of act as like additional documentation. I want people to see these and go, oh, yes, these logs have PII in them. Great, right? Like that's great, right? If you have these variable files and maybe it doesn't have literally all the variables in it, you can give people a really nice boilerplate to solve that blank slate problem, right? I'm looking at a module, it's got 10, 15 inputs. I have no idea where to start. Yeah, sure, there's all these descriptions, there's all these validations. I got a couple of examples here, but like the example's called MySQL. It's like, okay, the entire thing is MySQL. What does that even mean, right? It's an analytics database. It is a high throughput write database, right? Like there are these cases that you're going to use these use cases in, right? And try to capture some of those. So when a developer comes in, they see the name of the thing. They go, oh, that is exactly what I want. And they can grab those vars and get started with them quickly, right? The presets make it easy for them to get started without configuring everything from scratch. Depending on like how complex the service footprint is of the module that you're designing, you might even see that somebody uses the var-file flag multiple times to like, hey, I just want to grab the PII one. I want to grab the presets that you said I should use for PII. I actually don't care at all. I know that I'm supposed to care, but like, give me what you got, ops team. I'll take it, right? And you can actually use that var flag multiple times. Or I can copy those files to my repo where my invocation of this module is, and I can fine tune them, right? You should look at these as a framework, like not a cage, right? Like it's not something that's like trapping the engineer into like a specific set of options, something to just get them going quickly. Now, they solve this blank slate problem. They act as a bit of documentation. Those are both really, really powerful. I think one of the other things that is really interesting about designing really good presets that make sense is they can start to act as your test cases, right? Like we don't do that a lot in infrastructure. We don't test, right? Oh, we test in prod, or actually we test in like pre-prod, right? We deploy the thing and we're like, well, Terraform says it's green. I guess it works. And then it doesn't because, things work different when they're using them, right? So we don't do a ton of testing, and there's great tools like TerraTest. If you're familiar with Go, I think that's the better tool to use when testing infrastructure, but I also write a ton of Go, so I'm fine with that. But then there is Terraform and OpenTofu test that you can actually just write HCL to do some tests. And so what's really cool about these presets is if you are treating them as, hey, these are really good getting started configurations for this thing. They're not just examples and half-assed documentation. They're real documentations that's actionable that you can use and extend. Use those to vet that the module actually behaves the way that you expect it to in those cases, right? So if I've got 2 presets for maybe an RDS, I've got an analytical one where it's very read heavy, and I've got maybe a transactional one that's more write heavy. I can actually stand up to RDSs and vet that those use cases are met, right? And so I think that this is one of the really cool things with presets is not just seeing them as basic examples, but trying to get as many birds killed with one stone from them as possible. And so, like I said earlier, like it's not a super exciting thing to work through, but I think the impact when you use them effectively, it pays multiple dividends. And so what we're going to do here is we're going to just create a couple of presets. We're going to say, hey, we've got a lot of teams that are using this to handle some sort of photo upload, whether it's it's a profile picture, or it's part of a feed or whatever. Maybe they're just using it as, photos or images that are just on the site, just like regular static assets. Or maybe somebody has temporary file uploads. Maybe somebody is pushing FTPs to this, and then we're doing some processing, and we don't want to keep that stuff in the FTP directory forever, right? And so what we're going to do is we're going to make 2 presets. And so this one isn't super exciting. We're going to make a couple of TF-var files, and we're just going to literally fill in what we've done so far. And this is kind of what we'll do. So I'm going to switch back over to this repo. I'm going to make a directory called presets, and if you hate the word, call it examples, but treat them a little bit more than just documentation. All right, like that extra effort is magnified, right? Like this is something I'm like pretty big on. Like when we find the time as ops engineers, recruiters love to say ninja and rockstar and 10x engineer, but the truth is like the only real 10x engineer in an organization is a properly functioning operations team, right? We are the engine for the entire engineering org. And when we start to get the time to do these niceties, these aren't niceties that pay off one-to-one. These are niceties that I come in, I understand how the module works, and I was able to get moving faster, right? Corey might not get a pat on the shoulder as the ops guy, but that developer's thinking, wow, that was a lot easier than it was last year, right? And like that's, whether I get the pat on my shoulder or not, like that's what I want to see happening, right? And so boring concept, but I think it's powerful. So we're going to go ahead and just create a couple of these presets. We're going to make one called, where is my, we'll just do temp file uploads, .tf-vars, and then we'll do another one called, what did I say the other one was called? User avatars. Okay, and these are going to be pretty boring. So if we hop back over here, I think I get a couple of examples. Great. It's avatars, temporary file uploads. There's actually a fourth benefit to these besides like the documentation, getting dev started, and the testing, and that is you can actually feel what your interface feels like, right? So we know that we've got these variables over here. Let me just drag this to the side so we can see them side by side. So we've got region, right? US East 1. Now that's the one that everybody picks, but But the fun thing with US East 1 is like maybe you're an organization that knows that 16 out of the last 23 major outages of AWS happened in US East 1, and you're very, very not pleased with the idea of the cloud failing underneath you, right? And so maybe you actually want to tell developers, hey, we should be running in, US West 2. We don't want to lock them down per se, but we do want to give them guidance, right? And that's what we're trying to do with this, is give them guidance on how to get started. So let's keep US East 1 just so everybody's saving the most amount of pennies. We will go ahead and add a bucket name. and we'll just call this your bucket name here, right? Giving them that guidance of what they're going to need to fill out. We're going to give them a retention policy. So this is the user avatar. So looking over at my retention policies over here, thinking about like, okay, somebody's uploading their images to the site. Well, we want to keep those forever, right? We don't want to delete user avatars. That'd suck if you logged in one day and it was just gone. Like my Reddit icon is, Reddit banned my icon. Go figure that one out. And let's do versioning policy. So we'll say that we don't need to keep any versions. Once somebody changes their avatar, we just change it. And maybe we want to do some notify events. Maybe we want to do something like S3. See, this is why it's important to give them guidance. I don't even remember the name of this one. I think it's object. What is it? It's object created. That's what I'm looking for. Right. So it's giving me a little error, I think, because these aren't in the same directory. I'm not going to worry about that now. I think if you drop it right here, it'll clear itself up. No, it's being a little goofy. Region, bucket name. This is just VS Code being silly. Let's check. Tofu, plan, var, file, user avatars. Okay. Yeah, it's just VS Code being silly. I'm going to throw this back in the presets directory. And then we'll go ahead and do a temp file as well. Your bucket name here, for, okay, I spelled ephemeral wrong someplace. Where did I spell it wrong? Is this how you spell it? Hold on. This is how I spell check. Does everybody else just do this? They just Google it. That's my spell check. Trying to make it as expensive as possible for the old Googlers. We'll say it's ephemeral. The versioning policy, we don't need any here. And then let's say that we don't need any object, right? This is just like some temporary file upload, right? So maybe my application just needs to store some files. I need some disk, but I don't have, maybe my application's running in Kubernetes and I don't have write access to disk because, we're using, some sort of hardened container, right? I still need to write some files someplace and it just needs to be temporary. Well, bam, here we go. I can write it to this S3 bucket, right? And so now I've given two very common use cases for this module. I've given you some configuration that makes sense. Now as a developer, I can just grab this tfvars, name it prod.tfvars, staging.tfvars for my two different environments, fine tune the fields here, and boom, I'm off to the races. So I said, this one's kind of boring, not super exciting, but it's one of those things. It's like if you just spend enough, you just spend the extra time on it, like you can get a lot of different benefits out of this. Check over here for questions real quick. I appreciate that, Robert. I always wonder if I'm just like talking out of my ass. Okay, derived naming and tags. So this one is I think this one's exciting. Well, it's boring, but it's exciting, right? Like this is one of those things that nobody's jazzed about. Like nobody's super excited about naming things. People are certainly not excited about tagging things. I am someone who loves a good cloud tagging strategy, and I don't know that I've seen very many companies that had one, right? And so it's hard to get tagging. It's hard to get tagging right. And it's hard to get people to do it, right? Like there's not a ton of validation around it. You can build validation around it, but it's going to be pretty painful. And so what I love about this idea is coming up with a consistent set of fields that you probably use on every module, right? Because every module is owned by a team. Every module is a part of a project. Every module is running in some sort of environment. Every module has a purpose, right? Like, let's say that we have a Redis module. I might reference that module twice in my main.tf. I got once for page caching. I've got once for user session. They have two very different purposes. I have two different clusters, right? So there's a lot of these attributes that we assign to these resources, but then forget to add in tags, right? And so by creating a consistent interface for this label-ish data, you can force people to input it, and then you can put it in the right place in the tags. You don't have to worry about them getting the key wrong, right? You can do some validation on the value, right? Like maybe I want to make sure that the environment is prod, QA, pre-prod, and preview or something like that, right? But then you can start doing some really cool stuff, depending on like how far along your operations team and how much bandwidth they have. Things like cost center. Nobody knows their cost center. Does anybody in here right now know what the cost center number is for their infrastructure for any given project off the top of their head? Type it. Don't look it up. You don't, right? Like it's one of those goofy things. You're often Jira looking up, or you're looking in another, Terraform module to try to figure out what it was. But the funny thing is whoever's come up with those cost centers, they know who's supposed to have each, right? And so when you start to do this derived naming and tagging, and many times I will actually suggest that you make a module that does the name generation and your naming convention for all of your modules, that generates the tagging conventions for all of your modules. And there's actually a really, really great one out there by the team at Cloud Posse. If anybody's familiar with them, I think it's called Null Label. It's pretty great. It's a good one to get started, but it's another one of these where it's like, it's great. It's a good one to get started, but I'm always hesitant about using something that's literally just somebody else deciding how an API call is going to be made. So I like to take that idea and own it a little bit, because it lets you do things like, hey, you know what? Based off of the service and the environment and maybe the purpose or maybe the class of infrastructure, is it data or is it compute? We know what the cost center is. So instead of asking the developer to input it and potentially get it wrong, we'll set it for you. Maybe we're just hard coding a big matrix of attributes in our module that pops out a cost center, or maybe we have, an API internally that we can hit with a query string that'll tell us what our cost center is as a part of this module running, right? Like, how do we get developers to move quickly, put in the right values, account for things without just loading them up with just this technical debt and like process over and over and over and over and over again. Like the cost center is such like a red tape thing to go look for when you're just trying to spin up a database really quick, right? And a lot of developers are kind of, how about using for auto tagging? Yeah, I think it's great. That's what we're actually going to do is we're going to do some auto tagging here. And I think you can do a lot, right? There's a lot of different tags that are important to different businesses depending on how they run. And if, it's one of those things, again, it's like, it's not really validated if you're just putting it on the tags, any object. But if you start to formalize them as inputs to modules, because they're common, and then you can take those inputs and derive the rest of them, whether it's through some logic in locals, or whether it's an API call to some service that you have that can help figure that out. It's less for the developer to do and more consistency for you, which is going to be less maintenance work for you to go fix it and figure it out when the CFO is pissed in 3 months because like, where'd all this cloud cost come from? It's not being attributed back to a cost center. It's like, oh man, somebody forgot to add that tag. Whoops, right? So we'll go ahead and work through this. We're going to build our own little version of like the Cloud Posse Null Label, but I'd say definitely check that module out. It's on their GitHub. It's open sourced. It's definitely a cool module. So let's go ahead and get cracking. So this is presets lab number 4. So we're going to create this module. And what this module is going to do is we're just going to take a couple of inputs. We're going to keep it really basic. We're going to take the project that the resource should be a part, or the module is a part of. So maybe it's the profiles team, right? Or the profiles project. The environment that this is running in, or stage. Some people call it environment. Some people call it stage. What even is an environment? The name for this instance of the module. Now, this isn't going to be the actual name. This is going to kind of be like the purpose of it. This is my session cache for my project in staging. This is my page cache for my project in staging, right? And we're going to take all of these attributes and combine them together into a naming convention that our business uses. So we're going to say, hey, name's got to be less than 40 characters in the cloud, and they're composed of project-environment-name. Now, another one that is interesting to include in here, and I kind of just put it in here as a purposeful gotcha, because I've seen people do this and feel really good about it. and then it explodes in their face. When you're deriving the names of things, and this is a good thing and a bad thing with this. When you're deriving the names of things, if the name changes, that might be fine. I changed my name. My last name is not really O'Daniel. Figure that one out. Not because I'm married, but I changed it because it sounds cooler. I wanted an apostrophe. I wanted to break Southwest Airlines every time I booked a ticket. But when names change in the cloud, sometimes it deletes a database and recreates it, right? And so I've seen people put the team name in a cloud resource, and then the cloud resource changes the team that owns it, right? Not the project's always really the same, but the people that are running it changes, right? And now you're like, oh, I need to update the BR team. It's used in the name. Database is gone. Database comes back up, but there's no data in it. Uh-oh, right? So the team is probably important. It's nice as an ops engineer to be able to go in to some cloud resources. Maybe I want to slice stuff by team to see who's kind of doing what, or I found a resource, who owns this. It's this project, but there's two teams that work on this project, right? It's the API. There's an API team, and there's a whatever team, a video streaming team, right? Who actually owns it? Well, I want to put that in the tagging information so I can find it, but I don't want to put it in the name, right? So I kind of put this here as a gotcha just so we can kind of call this out, because I've just seen people just really get into deriving these names and building naming convention logic, and then they stick something in there that just kind of ruins their day. And then what the module is going to output is a couple of things. It's going to output what we're going to call a name prefix. And this is going to be the project-env-name, not dash suffix. Forget that. It's also going to spit out a random suffix. And it's also going to output a map of tags. And so what the name prefix is going to be is just going to be that. Sorry, I got a typo in there. It shouldn't have suffix at the end of it down here at the bottom. So what that's going to be is it's just going to be the name prefix. And we can use this for a lot of different cloud resources. So you look at a lot of AWS sources like S3, like there is a bucket prefix, or you can set bucket. So bucket lets you fully control the name. Bucket prefix is a provider construct that says, hey, I see the name that you want. I realize that buckets are global. So I'm going to just inject about 1 million integers on the end of this thing to make sure that you get the name that you want, but it's not going to have some global collision, right? That's great when the provider supports it. But the reality is not everything that we're building, even if we use AWS, is going to be using the AWS provider, and not every single resource in the AWS provider has that functionality. So by generating these suffixes, it gives us the ability to take the name prefix and use it on one of these prefix attributes when it's exposed. And when they don't have it, then we have this nice little suffix that we can use to kind of tack on the end of it to make sure that that name is unique, right? And there's it's one of these things, again, for developers, they want to have a name on there. They want to see it, right? But they may not know where conflicts lie in naming. And that's one of those things that sucks to figure out after the fact, right? So if we can just put a little random suffix on the end of there, and two teams happen to have a resource that's same name, or hell, two teams at two different companies have a Dynamo, or not a Dynamo table, and S3 bucket with the same name, boom, they don't collide because the suffix is different. So this one's going to be pretty straightforward. We're going to make a modules directory. And so I would generally put this not as a child module in your module. I'd make it as a published module that's shared across your org. We have a nice naming and tagging conventions module that everybody can use. And here I'm going to make one more. And I'm going to call this thing, what am I going to call this thing? I'm going to call it resource naming and tagging, maybe. Oh my gosh, it's fun. Resource naming and tagging. Now, again, naming things is hard. That's why we're doing this. I know that the name of this module sucks. If you have a better idea for it, let me know and I'll update it. But that's what we're going to call it for now. So I'm just going to make it a main TF here. We can break this out into individual files, but I'm just going to kind of go through here and add the things that we mentioned. So I want to do these inputs. Can't spell, but man, am I good at multiple cursors. Am I right? It's one of the things my mom's most proud of me about. Okie doke. So that got all my variables in there for these, right? I may want to have some, maybe I want to do some additional validation. Maybe I want this to be a string. Maybe we've standardized on environment names. Like this is honestly like project's a string. We'll probably put like a length, you'll put a length validation on it. Name, string, length validation, but environment and stage, my gut is it should be an enum. I don't know how many times I've popped into a AWS account and I've seen prod, DB, production cache, right? Production cache, like people just type whatever they want, right? And so getting that consistency is how we get consistency. So when we can restrict inputs, I like to do it. So it may be nice to kind of throw in a condition here. So let's just go ahead and do that. Validation, condition equals contains prod, staging, QA, and let's say preview, maybe for like we have preview environments or something that we're standing up. Var.environment. Right. Now, probably a little constraints there. So this module, as far as like functionality, may not have any resources in it, depending on what you're doing. So we'll go ahead and we'll just start here at the outputs, and then we'll come back to the resources in just a second. So this is something that's actually pretty cool. You don't have to have resources in your modules. You don't have to have providers in your modules. You can actually just use them to pass inputs, do a bunch of locals, and spit stuff out. So I'm going to add a couple of things here. I'm going to add output, name prefix, and the value is going to be, let's just do join. Yeah. var.project, var.environment. Hold on, I'm gonna hot question alert for the channel. What do you like first? Do you like the project, so you know like what it's related to, or do you like the environment first? I have a preference, but I was told my preference was wrong recently, so I'm curious what other people think. I like having the environment first. Like there's no question in your tab completion. Like the tab completion sucks a bit more. You hit P, RO, and you're gonna get everything that's prod. Yeah. Oh, project Terry. No. Okay. Oh. Okay. So there is a disconnect. Okay. I just want to make sure that I want to make sure that I was like 50% wrong and not 100% wrong. I'm okay being 50% wrong. I like environment first, but I've seen people just tab their way through a project. Oh, that's my project. Boop, boop. And they accidentally pick prod when they meant staging or vice versa. So I like making people think about the environment first. But okay. Well, we already started with the project first, so we're just going to stick with it. But I'm on Phil and owner's side. Owner. I love an environment first. Okay, so let's go ahead and toss name on here. Now, what we'll probably want to do is, this is all your organization's conventions. Everything that I'm doing here, attribute names, the enums I'm listing, doesn't matter. What matters is what your team needs to do, right? And backing them out into these ideas. So I'm going to do this order. I'm just going to hyphenate it. One of the things that's nice about the Cloud Posse module is there are a lot of different validations in naming things in the clouds, especially between different clouds, but even between different resource types. Like some of them have, I think a bucket has like, 30 something characters. A database might have like 64. So you may, the Cloud Posse allows you to like actually like enforce like a length limit when it's generating the naming convention. So you may just want to be weary of that. When we first started MassDriver, in that GIF you saw earlier, you saw that it generated a naming convention. We spent probably 2 or 3 days looking through all the resources for all the clouds, trying to figure out the lowest common denominator of a naming convention that would work across like the 3 hyperscalers. And it was a ton of effort. So that's just one thing to note there. Like your naming convention may be too long for some resources. So it's just one thing to watch for there. So we'll just do this for now. So you might want to put length validators on name, project, etc. I'll leave that up to y'all. Output suffix we'll come back to in a second. This is going to be the one resource that we need. And then there's also going to be an output tags. And so this is where it starts to get cool, in my opinion. So we can do something like, okay, well, we want all of these things while they're using the naming convention. We also want them to be tags, right? And so now what we're doing is we're creating a standard interface for all of our modules. All of our modules are going to require you to tell us project, environment, name, team. And we're going to make sure that those are the base set of tags. Find the name. Yeah, I'll put a post on it. Let me toss this in my notes. This is we actually have a this is how I take notes. I just Google it and then have a tab open later. We actually have a architecture decision record internally of like how we came up with it. So we actually kind of have it like an internal blog post already, almost to describe like why we do the things that we do. But yeah, I'll throw that into a little blog post. So what's nice here is like now we're formalizing some tags, right? So this might be our base set of tags. Maybe this is what we use in the default tags block of like the AWS provider, right? Maybe we let our developer customers pick some of their own tags. Maybe they want to tag out some additional stuff, but we're going to make sure that they have the ones that matter to the business. So I'm going to go ahead and do environment equals var.environment. And we can do things like, hey, maybe, we call it environment as the field, but, ops people hate typing a bunch, so we're just going to call it env, right? Like we can control the keys, right? Like this is actually a formalized structure of what our tags are going to look like now, because we actually can control it through these through this module. So we can say, maybe we want to capitalize these tags, or maybe we want to lowercase them, right? Depending on what cloud it is. I'm going to call it environment though, because I'm going to forget that I called it env. And then we'll also add team on here. We want the team. And what was the one thing we're missing? Var and right. So we called it name. So it was real easy for the developers that, I'm going to name this thing. But maybe we track that as purpose internally, right? We can name this whatever we want. And then we can inject this will come out as tags, and then we can merge with other tag sets. So if we want to expose an additional tags that the developers can put their own tags in, we'll probably do like a right-hand merge where their tags are essentially the baseline and ours will get merged over, so that we always have those conventions there. Now, the other thing you can do here is like, this is where you have the ability to tap into things like, data HTTP. Like let's say, I don't have a server set up that does this, but let's say that we did have a server, just a real basic server someplace where we just take all these attributes and we can tell you what the cost center is. I can make a call to that, pass in the information, get the cost center ID, and just inject it right into their tags. The developer never has to think about it. That's great. There's probably a lot of different attributes or tags that you have that are these things that developers don't care about, but they're always having to ask somebody what they are so they can type it in. Like that is, I have to Slack you so I can type this in. Ugh, no one likes that. So you can do that. I've also seen teams do things like this is just like a real nice lo-fi one. You might have like a matrix of cost centers, right? So cost centers equal, and then maybe it is your environments, prod, boom, and then right, like the team, boom, right? Like you might just build a tree of it and just have that literally codified in the module. It is a lot to move around the module if you start to get to the point that you have a lot of cost centers. But if you're just starting to get into it, like it might be easier to do this than to build a little web service that does it, or buy a little SaaS that does it. It's a great way to kind of just hack it in there. And then the suffix will be the last thing that we add here. So what we're actually going to do here is we are going to add one resource for the suffix, random. Ooh, I should know the name of this. It's random string. So I'm going to call this one suffix. And I'm calling this one suffix just because, your convention module is like a little bit of a grab bag of a bunch of different concepts. And so I can see a point in time in the future where there's realistically going to be another random string in here for some reason. Maybe we need to generate an ID or whatnot, right? And I might even go so far as to call this something like name suffix. And so I generally lean on this because we're doing these use case oriented modules where it's like, this is the database that I'm making. There's not two databases in here. There's no point in naming it this, that, and the other, right? Now, if I'm making IAM policies and I've got 3 of them, I'll probably name it read, write, and admin, right? Those are my 3 different resources. But this is one of those places where I've just seen, you know, a module that is so central to every other module that it doesn't have a blast radius in like the way we normally talk about blast radius, but it has a break radius that can be pretty painful. So if we come along later and we just call this, and then later we add another random string and we give it a name, now like the naming here is confusing. What is this? There's this other string that we're randomly generating that has a nice name, but this other one's just called this. Maybe we put a comment above it, or maybe we make the decision to change the name and the potential impacts of every single module that calls that thing. So there are ways to get around this. There is an import block now in Terraform. You can actually like move resources declaratively through your state. That's a really good option. But this is one of those things. Is like it's nice to call out, because if you're not familiar with those newer features in Terraform, like the import block, like this could be a state nightmare if somebody just thinks, oh, I'll just make that name a little better, and then don't think about the impact of that. So sometimes I feel like naming things a little more than just this can be fruitful. So again, it's all about designing for your team, right? So I'd say if you're one of those teams where you're like, oh, I've got a seasoned, ops engineer, DevOps engineer, whatever. They've been in the space for 15 years. They've been using Terraform for 8 years, day in, day out. But you've got 3 new people on the DevOps team that are just starting to cut their teeth, right? Like, you probably need to build some protections yourself in your code, just because your own team that's working on it may not be deeply familiar with it, right? And so I think that developing for your team isn't just developing for your end users, but even developing for your own operational team and their expertise, to make sure that you're not foot gunning them. Because again, like, they can be your 10x engineers, but when they foot gun, they can turn into 0.1x really quickly, right? And so like, this is a place where you can really, really blow things up. So I'm just going to call it naming suffix. Talked about that for a long time. And then the output here will be value equals random string out suffix dot result. Right, and so now we're going to get a name prefix. That's really nice. We're going to get a suffix. We can put them together if we do need to have a unique name, and the cloud resource doesn't have like a name prefix functionality. If it does have a name, if it does have like the prefix functionality built into it, where it's going to append something to the end for you, I can just pass in the name prefix, and that's what we're going to do with the bucket here. But this is a pretty good module. And so what I'm going to do is I'm just going to vet it real quick. I'm going to go for those green leaves. Switching the modules here, tofu init. Just make sure that it's all copacetic. There we go, tofu format. Nice. Okay, so that's good to go. And so now, and again, I would normally have published this to its own repo on Git. I would probably do like very hard versioning on it, like pin it to a 1 point whatever. Wouldn't actually make it a submodule. It's just a little easier to walk through the workshop this way without having to jump into a bunch of Git foo. And so now I can use this from my main module here, right? So I know that I'm going to have this module that manages my naming convention. So I'll do module metadata source equals, so that's module, and I know that I need to pass in a few things. So this is going to be, my project is the profiles project, or our social tool or whatever. The environment is, maybe this is prod. The team is social team. And the name of this is the avatars, name, purpose, use, etc. Right? So now I've kind of got everything punched in here. Now I'm going to want to back these out to variables myself. And variables on my module, but I'll come back to that in just a second. In the meantime, I'm going to do module.metadata.name prefix, and then I'll switch this to actually be the bucket prefix. And so now what's going to happen is we're going to use that naming convention. The AWS S3 bucket module will go ahead and append a string to it. This one supports it. I want to use that. But if it wasn't, then I'd probably do something like name suffix. We will get the name suffix, right? So now what I'll do is I like to make sure that all of mine are kind of following this convention. So this is going to, you got a couple of options here, depending on how you want to do this. So this, if you're familiar with like the underlying data structure and in Terraform and OpenTofu, there's this concept called the DAG, the directed acyclic graph. And so if you do resource references like that, it'll actually organize how you roll stuff out. And so what this is doing is saying, hey, don't make this SNS topic until the bucket exists, right? And so when the bucket exists, the name will be here. And so then this can happen. So Terraform is able to figure out like what order to deploy these resources in. Now, the interesting thing is just minor tweaks, but like you can actually squeeze just like a tad bit of performance out of this now because we have this standard convention. I can do name prefix, and it's going to be named the same as the bucket, but now this isn't dependent on the bucket. This resource isn't. Now, this resource is, right? This resource is actually dependent on both. But now what's happening is if I've got, multiple CPUs where I can actually like do some parallelism here, I can actually start creating these two resources at the same time. I don't have to make them dependent on each other just to get that name, which is kind of like a cool little tweak. YMMV there. So we've got this in place. The one other thing I will go ahead and toss in, we're going to come back and we're going to fix these in a second, but I'm going to go over to my provider, which we haven't really looked at much, or maybe not at all. So this is just where you configure your providers. If you are any of the folks that are newer to Terraform, this is where you say like, hey, I'm specifically going to be using AWS. This is where you can kind of do your package.json-esque stuff of like, here's the library I need, here's the version. Whoa, that's a slip. And one of the other things you do is a lot of different resources on the provider, but there's this concept called default tags. And so what we can do is module.metadata.tags. And now every single resource that supports tagging in AWS will get the tags that we've input there, right? So I don't have to think about going around and tagging everything. Now, if you do want to allow your developers to do their own tagging as well, you'll probably want to do something like, I think it's merge. Yeah, merge. So I'd say like var.additional tags, like their tags, and then our tags last. And what this will do is if they make a tag called project, ours is going to win in the merge. I think. Can never remember if it goes left to right or right to left. But you might want to do something like this if you want to expose additional tags, but we'll just keep it as the metadata for now because this is good enough. And now we're going to get everything tagged, which is pretty cool. Now, the last thing I'll do is I got rid of that name prefix variable over here, or bucket name. That's bye-bye. And now I've got these ones that I'm going to kind of put in here. So variable. I'm not going to set defaults because you need to put those in. And then over here, var.project. Now, there is a really cool solution for what everyone's probably thinking right now with using something like Cloud null label or this resource naming convention thing we just threw together. What's really nice is it gives us this consistent interface for generating our names and our tags, but it also creates a lot of boilerplate for all of our modules, because essentially every module now needs to expose these fields right here so developers can enter them. And so the last section that we'll talk about today is an open source tool that we make called Airlock that we use for validation and whatnot. But one of the other features that it exposes is the idea of essentially drying up and creating contracts in infrastructure as code. So we can say, we have a contract for resource naming conventions that exposes these 4 fields. And now we can just say, hey, like my module respects this contract and it'll automatically do all the field names for you. So it can really save you from like, if you have these places that are extremely repetitive, you can kind of cut that down and lean on contracts. But we'll get to that in just a bit. So right here now, we are actually asking for all the fields that we need to be able to make this resource. We're passing all of these through. I should hopefully get tofu format. I know I got some funk in there. Validate this real quick. Module metadata is not yet installed. Tofu init, we'll pull it. Sweet. And now, like, if we stop and we think about our developer story, what it's like to use this module now, right? We got this user avatar here. We no longer have a bucket name. And you probably don't want to include your metadata in like these specific use cases because they're going to be really, tied into a team. You might add it, you might not, but if you add it, I'd put like your environment here, your project here kind of stuff. But now you can start to see like this becomes really easy to get environment. Right, so now I can do tofu plan, var file, and again, the developer would copy the var file that makes sense for their getting started into their repo. But I'll just kind of edit this one here for now. Oh, I deserve a sip of coffee. That's nice. And so now I'm able to make a pretty complicated bucket with a lot of functionality without me knowing much about AWS and S3. And like, this is the goal, right? Like, I feel like a lot of teams are kind of afraid of like, oh, well, we've created an abstraction. And to go back, as I said at the beginning, is developers are used to using abstractions. They build them all day long in their applications. They use them when they run on a PaaS. They're using them when they run on the cloud. That's an abstraction over their VMs, right? It is fine to make an abstraction. And it's also fine to know when it's not the right use case for your abstraction. And I feel like that's what we're missing on a lot of teams is we end up in one of two places as ops teams a lot of times. It's either we're writing these big modules that try to support everybody and they kind of grind to a halt. They're very hard to maintain. Or we're literally writing a module for every single person that asks for stuff, right? And we're seeing commonalities between these things, but we're not approaching them in like a holistic like design manner. We're kind of like designing after the fact. And it gets very hard to kind of maintain 1,000 different invocations of, making RDS database. And so this is, again, like we're aiming for this 80%. Like this might be a great contract with our developers to kind of lower the surface area of the cloud, give them the functionality they need with our guardrails. And the cool thing is like, we might want to go touch some OPA and some Chekhov, but we've already done a lot without bringing in another tool. Like you can get pretty far in Terraform before you have to start grabbing other tools to do, this validation and vetting and policies and whatnot. So this is something I love, right? It's great to be able to say, hey, these are the inputs you put in. You didn't have to learn how the service worked. You get something that works extremely well in prod. And I didn't have to worry necessarily if you remembered to copy the CI script for running Chekhov, right? Like I've encapsulated this into my module. I've put a lot of thought into how our team works, compliance and security requirements that we have, and actually embed that into how it works. And it's easy to do when you're thinking about abstractions and use cases. It's hard to do when you have no abstractions because you don't know how the person's going to use it. So this feels pretty good. Let's hop back over and check out the next section. So the next section, I think, is probably one of the coolest. It's also another one that's like fairly boring. But when you start to think of these modules as use cases, then you are the subject matter expert over what a logging module looks like or what an ETL bucket looks like. And you as the subject matter expert of something that's very tightly scoped, understand the IAM as well. It's very hard to understand how to do the IAM for an S3 bucket. What does it do? Is it storing stuff from Redshift? Is it a CloudFront distribution source? Is it a multi-part upload? Is it an FTP receiver, right? Like, what is it? Like, the bucket is so vague, it's hard to think of what is the right IAM policies. But when we're thinking about something like application assets, where users are uploading something to our backend and we're storing them in S3, I have an idea what the IAM policies look like for that. And what I want to do is expose some principle of least privilege IAM policies to my developers and say, hey, you have your bucket, it's yours, you own it, right? That's self-service is ownership. This is your bucket now. You're going to need to read and write from it, right? And what I'm going to do is I'm going to make 2 policies for you, maybe 3, maybe 4, maybe 5, whatever, how many policies I think make sense for this. Maybe I start with 2. Some people give me some feedback that it would be useful to have a 3rd one. Maybe they need an admin one. It makes sense for the 80% use case. We'll put it in. If it doesn't, let's fork this module and let's guru something for your team, right? And so what's nice about doing these policies as outputs is, A, putting them in a consistent place so developers know, hey, there's a policy object that's going to be there. It's going to be some names. Maybe even do a little more than this. Maybe you give it like a key that makes sense that they can grab off of, and maybe actually give them a description of like what it is, right? You can also put that in the policy itself, but and then the yarn, right? I'm making the policy. Now, some teams like to actually push the policy blob out versus an actual like creating the policy in the module and then pushing out the yarn. It's trade-offs for both. If you push out the policy blob, it's up to the receiver to take that policy, make a policy, bind it to the role. If you know that these are pretty common cases and people are going to be using them, making the policy inside the module might make sense. And now they just have to bind a role instead of thinking through some additional resources there, right? And so what we'll do here is we're just going to add 3 policies. We're not going to actually do read, write, and admin. We're going to do read, write, and subscribe. And the subscribe one will be conditional, right? If there was an SNS topic, we will push out the policy for subscribing and attaching to this SNS topic so you can, SQS it or receive notifications or whatnot. Okay. So I'm just going to take the, no, I'll keep that in. So, okay. So we're going to do a few different policies here. We're going to do a read. Let's do a, what do we say in the doc over here? Where is it? There we go. We're going to do a read policy. We'll do a CRUD policy, right? So I've got a backend that's using this. I need to be able to show the user that they have an avatar already. Do they want to replace it? Yes, they want to update it. I'm a new user. I need to create my avatar, right? So I know that this is an application assets bucket. I think there's probably going to be some CRUD that the backend that's actually receiving these updates need to do. So I'm going to give it a nice CRUD policy. I also know that in reality, when you start storing things in buckets, there's other services that may need to read. I'll also produce a read policy and push that out, right? So if we have maybe a Lambda that needs to read off of this, bucket for some reason, it can access that. And then I'll also make that subscribe policy, push that out as well, so that we can attach different resources to those event notifications as they come out. And then we'll just output that in one nice little JSON blob. Okie doke. So just for people that are newer to Terraform, I'm just kind of appending everything to the end of this main.tf. There's a lot of different opinions on when to break up your Terraform modules, or not your Terraform modules, your Terraform files. I tend to like just MOPV, main output providers and variables, and going with it as long as possible. But you can definitely see places that you get to where it might make sense to start breaking them apart, right? So when we get to SNS, there's going to be, I think we're actually missing a little bit of, I think we're missing a policy right here, right now. I think we need to add a policy to say that the bucket can actually notify the topic, right? We're going to end up with another policy to say who can subscribe to the topic. We already got 2 resources here for the topic. Like, there might be a point where you say, hey, you know what? Main is going to be my S3 bucket, and then I'm going to add an SNS.tf, and I'm going to move all the SNS stuff related there, right? I like to just keep it in one until it's just absolutely heady. What is heady? Whatever conventions your team comes up with. But if you want to start splitting it out just for your own sanity, or you want to see things side by side, like that's usually my go-to is like, shit, I need to see two of these things at the same time. That's when I'll start kind of breaking stuff out. But for now, I'm just going to kind of let it rip. So we'll do a resource, and I'm going to copy and paste these because I am not an IAM guru like most people on the planet are. And that's why it's really nice to output these policies, because you certainly don't want devs to think about it, because you know what they'll do? They'll put an asterisk in. You knew I was going to say it. So I got a couple of these already built from the workshop that I uploaded to GitHub. I'm just going to kind of blob all of these policies in real quick, and then we'll kind of talk through them. There we go. So I'm going to make a read policy. I'm going to use the metadata, was it name prefix? I think I called it something else in my other. Use the name prefix. Now, why the name prefix, not a suffix? I can add the suffix on here if I want. I think it comes down to your team being familiar with like where the uniqueness constraints lie. If my entire team is using this metadata module correctly, and they are putting in their names and environments and projects, then I've technically already solved the uniqueness problem. I may not need that suffix on there. So I would choose not to put it on in this case. I honestly hate this. I know it's a policy because it's a policy. When it comes out as an ARN, I know it's a policy because it's in the ARN. I don't need it at the end of the ARN as well. So I usually just kind of do the name prefix and then like what the actual policy is, read, CRUD, and then subscribe. And so we're going to have 3 of these here. The read one's just going to give you access to get and list the bucket. Again, this is you as the subject matter expert of like how to design application S3 access in your organization, figuring out what IAM rules make the most sense here. You may or may not have just these 2, but kind of hitting all the CRUD things, so you can get, list, put, and delete. I still call it CRUD just because it's really hard to say glip, GLPD. Are there laughs happening in here at all? And then the final one is subscribe. You can see with the subscribe one, we're going to conditionally do it. Now, as I noted up there, it's really nice to be able to have that enable notifications on. I might even rename that notifications enabled, right? Like now I know when I'm going to be creating this without having to like think through the ternary there and the additional length calculation. So I've got these 3 policies. I'll pop open my outputs now, and I'm going to go ahead and make one output here. Okie dokie. What do we got? We have read equals AWS IAM policy dot read dot ARN. Oops. Okie doke. And one thing here is the subscribe policy. Now, this should fail. I should get an error, right? To validate. Yeah. Did I get an error in the wrong spot? Where did I get an error at? Name. Did I leave something called name? Name prefix. Got them all. There should give me a failure. Should give me a failure on that subscribe, right? Yeah, there we go. Okay, sweet. So this is another place where I would end up using the local dot enable notifications. And policy subscribe. Or no. So now I should be able to validate this. And effectively, my output here is going to have a read and a CRUD. Those will always have an ARN. Subscribe will be an ARN or a null, depending on whether or not subscribe is enabled. Now, you can do a couple of things here. You could actually build this whole thing in a local and conditionally inject subscribe into the map if it's there or not. I like key presence. I like types. I like inputs and outputs. So I'd rather say subscribe is an option. I'm not currently outputting it versus like hiding it from the map or removing it from the map. I just kind of like that interface, but I'd say choose the one that works best for your team. But we're good to go here now, right? So I know what an application asset module does for our business. I know how I want teams to be able to access it. I know that this access pattern makes sense for the general population on the team. And again, if somebody says, hey, this one doesn't work for me, then it's okay. Is this fit in the 80% use case? Can I go ping the rest of our team and be like, hey, is this something you guys have struggled with, needed, that you've made a workaround for? We're thinking about adding it. Yes, great. That's feedback. That's doing the old DevOps thing, right? And if it doesn't make sense, you have the time now to work with one of these edge case 20% teams because you've dried up so much of the not dried up, but delivered self-service on the rest of the modules by making something accessible to your engineers. Let me just clear this real quick and shut this. So I've got these policies, and so now we're to the last part. I think we're to the last part, and so the last one here is very different. So you may have seen you've definitely seen HCL. You may have even seen some of these patterns before, like the Cloud Policy Null label. Maybe you've done policies as outputs before as like a strict type. But the last thing I want to talk about here is schema-driven validation. And this is a separate tool we open source called Airlock. And it does a number of things. So first, to kind of tell you where it came from, MassDriver is a tool that, you saw earlier, you can kind of diagram your infrastructure as code. And if you saw on that diagram, there were these lines that connected the boxes, right? And so a lot of these principles and practices that we've developed come from a standard that we're planning to open source and hopefully submit to the CNCF, or specification that we call the bundle spec, which is a way of designing infrastructure as code. So taking a lot of these principles that we've done here, but doing it for all tools, Bicep, Helm, CloudFormation, Ansible, etc. Right? Like making self-service isn't always just about Terraform. There's plenty of orgs that are still running Ansible or maybe even running Chef, right? Like these engineers need self-service. Those are even harder tools for them to kind of understand and grok, right? Like there's a lot to them. And so can we kind of create these principles and practices around the way that we think about our infrastructure, where it's not just some fancy config, but a functional piece of software, right? It's a little tiny product that we're delivering to our team to kind of hide just enough of the cloud for them to be effective. And so as a part of this spec, one of the other things is prod's messy. Like prod's the messiest. I mean, I've seen people with a messy house. There's nothing messier than prod, right? And in prod, you have more than one infrastructure as code tool if you're doing IaC, right? And whether that's you migrating from, let's say you're using Chef and you're migrating to Terraform or OpenTofu, it's a migration. You're still probably going to have both of those tools in production for a very long time, right? But even if you just kind of snap your fingers, waved a magic wand today, and you got 100% infrastructure as code for your organization on all the newest stuff, you also have two IaC tools. You probably have OpenTofu and Helm, right? And so what the schema-driven validation does is it allows you to create contracts, not just between Terraform modules, like we're going to see with that naming convention module, but create contracts between IaC tools. And then once you do that, you can kind of get the power of Terraform's data remote state lookup. I don't know if everybody's familiar with that. The thing that lets you from inside your module reach into the guts of another module and like pull its outputs. Once you kind of get into schema-driven validation and these contracts between things, you can actually start doing that kind of connectivity between IaC tools, and not reaching directly into the guts and just pulling everything out like you kind of do with Terraform Data Remote State, but say, hey, we have these formalized outputs. This is what my module produces. This is an asset bucket. It produces a bucket. It doesn't produce an asset bucket. It produces a bucket. And we've formalized the idea of a bucket in our org. It's an ARN, and it is a map of policies, which is some sort of expression of how it's to be used, and an ARN, right? And now anything that's expecting a bucket can say, hey, I'm going to expect that bucket type. Now you can define that type in one place. And what Airlock lets you do is, validate the output of a module. So you can put this in one of your pre-prod environments and say, oh, somebody changed the outputs of the VPC module. We actually caught that, right? Like if you change the outputs, Terraform's just like, yeah, it's great. You can change the outputs all day long. But the reality is, if you've started connecting infrastructure and using data remote state and you change those outputs, you broke some number of Terraform modules that are out there, but you don't know which ones until somebody goes and runs it and they get an error that the outputs weren't as expected. And so what Airlock lets you do is formalize your outputs and then treat those types that are coming out of your modules as formalized inputs. So I can say, hey, my module expects a bucket. Maybe my Lambda that does the image resizing expects a bucket. We can actually say what a bucket is and say it's going to be more than just an ARN. It's actually going to ship some information with it, right? If I made a bucket and I don't have these formalized outputs, and I've got maybe 2 or 3 IAM policies that I want to ship principal of least privilege, I have to tell you what the policy name is. Now I got to tell you 2 things. I tell you the bucket, I got to tell you the policy name that you want, right? If you've got a Lambda, how do you know which policy you need? It's not in the bucket. It may come out of the bucket module, maybe, right? But like, how do you find this thing, right? Like, how do you know which one you're supposed to use out of the 3 of them, right? And so what Airlock allows you to do is validate those inputs. It replaces your Terraform variables. So your actual Terraform variables kind of go away. And what happens is you end up managing the variable interface to Terraform, Bicep, Helm, etc. through JSON schemas. And what this allows you to do is make a JSON schema store someplace. MassDriver does this today with all of ours. We just store them. They're open source. We put them under massdriver.cloud/artifact definitions. We've actually built a whole bunch of these for all of our customers. And what allows our customers to do is say, hey, we've got these primitive types for the cloud that we want to depend on, right? My application needs a Postgres. Doesn't care if it's RDS, doesn't care if it's an EC2 instance. What it cares about is it's receiving a Postgres. And we can say RDS produces a Postgres, EC2 produces a Postgres. Maybe there's a Kubernetes container that produces a Postgres instance. And now my applications can just say, hey, I'm looking for a Postgres. Anything that outputs a Postgres type can be fed directly into my application. So now what I'm trying to do is I'm creating these nice contracts, reduces breakage, helps us spot breakage and staging, helps us stop breaking a downstream application if it sees that the contract's been violated. But also, since it's JSON schema, it gives you an absolute ton of tooling that you can tie into. It comes with amazing validation. Like Terraform and OpenTofu has gotten some good validation over the past, year or so, maybe half a year to year. But the validation leaves some things to be desired. And so you can do like rich enums, regexes, conditional field validation with JSON schema. And so that's what we're going to look at with this last tool. So we're going to take the naming convention module. We're going to formalize its inputs, and then we're going to refer to that type in our module. So instead of having a variable for name, project, environment, and team, we will have a variable called metadata, and it will know that it is a blob of name, blah, blah, and team. And it allows us to manage that from that module that we're using kind of everywhere. And when it updates what its inputs are, you can actually push that into and update your variables automatically in your Terraform module, right? Without having to keep track of it, which is pretty cool. And then when you have your outputs, you take the same tool and you can validate the output from your Terraform to make sure that it's adhering to the contracts that you've designed, right? So it's kind of taking this idea of infrastructure as not configuration, but infrastructure as code, right? Like it's just configuration, right? We're making HTTP calls and just pushing stuff into the cloud, but we're calling it infrastructure as code, but we don't tend to treat it as formally as we do when we develop software. And so that's what Airlock kind of does, the final icing on the cake of, you know, taking these convention over configuration approach, taking the product and MVP, MVM approach to design these modules, and then finally formalize the things. There's inputs and there's outputs and there's something that is produced inside, but you don't really need to know what it is. You gave me some specifications. I gave you what the ops team thinks is the right thing for your workload. Treat this thing like a little bit of a black box and focus more on the inputs and outputs than all the guts. So this thing's pretty cool. There's a lot of different stuff you can do. It's the thing that powers the lines in MassDriver. So in MassDriver, you can actually like take these two things, like these two modules. Let's say I have a Terraform module that produced the Postgres, and I've got, let's say, a Helm chart that needs Postgres. I can put them on the canvas, and I can draw that line. And so in MassDriver, when you draw that line, what we're actually doing is kind of piping the Terraform output through Airlock to validate it. And then we're validating on the other end when it connects. And so MassDriver can actually reject connections and be like, whoa, my application requires Postgres 16. You just tried to give me a Postgres 15. Don't know how often that happens, right? Like if I brew install Postgres locally, guess which one I'm getting? If I Docker run Postgres latest, guess which one I'm getting? I'm getting the latest. If I grab the latest one from AWS, it might be a version behind, right? And so I can actually start to formalize the types and requirements and attributes of my infrastructure to stop breakage from happening. I can start to say, hey, I not only depend on Postgres, I depend on specifically Postgres 16. I don't care where it comes from, but that's what I need. And so that's what the tool does. So another really interesting place that we use this internally, and you know, we have a few hundred, I think, networks, and we got like 100 and something Postgres databases. I was looking the other day of how many people or how many customers use like our core modules, and we have just a few hundred databases. And what's cool is when we built like a whole library of modules that follow about the 75% use case for most of the cloud services for AWS, Azure, and GCP. And so our customers can kind of just like grab these, a lot of the stuff that we've talked about today, can grab modules that do most of the stuff, and then they can just kind of fine tune for their team. They're really good boilerplates to get you to convention over configuration. And what we ship in the types for ours is restrictions on VPCs and databases. And this was very important for us early on. I hope nobody minds the language, but one of our first customers was meeting with the CTO, and they were new to the cloud, and we were working through like setting up their VPC, and I said something about cider, and the CTO worked in the space for 12, 15 years. He thought I was talking about like cider. I was like, no, like a network cider. And he literally goes, I have no idea what the fuck that is. This guy puts things in space. Like, right. But it's just like, it's so far from like where he works day in, day out. Right. And so for him, like the idea of ciders and subnets and, routing tables is just a bit beyond him. Right. And it's fine. It's a bit beyond most software developers. Your network engineers know it. Your hardcore operations engineers know it. But the number of businesses that I've seen cross the $1 billion mark, and they're just running on the widest 10.0 network that there was, or the default one that AWS gave them, is plentiful. And I've made most of my professional services career migrating people off of poorly designed networks, right? And so what's really cool with the way that we design this internally, that I think is one of the other really nice benefits, is we've formalized our VPC artifact to have like essentially classified subnets. So we can say like, hey, this subnet is private, right? You can't really tell that from looking at the subnet. You can really tell it from the routing tables and whatnot, right? But now we actually have these tags in the output that says, hey, this is a private subnet, and this is an internal, and this is a public subnet. And then on the other side of this, our Postgres instances will not use any subnet that is not private. And so what's cool with that is for our customers that are like newer to the cloud, they've been on a pass, maybe they're running on, DigitalOcean, or they stood something up on Heroku. When they drop these modules and they're kind of getting IaC for the first time, they're not foot-gunning themselves by dropping Postgres into a public subnet. They actually cannot with MassDriver unless they fork their modules and their type and actually remove those restrictions from it, right? So that's one of the really, really cool things about the idea. And like I said, it's open source, so you can kind of just toss it into your CI pipelines today. It's nothing that's going to kind of lock you into our sales funnel or anything like that, although I'd love to lock you into our sales funnel. But let's go ahead and check this thing out. And my co-founder's here who's worked on most of it. So Chris, let me know if I'm typing the commands in wrong. Okay, so what we're going to do is Lab 6, airlock and JSON schemas. So this one's got like a little mini tutorial at the bottom. Works with a bunch of different IaC tools, but what effectively we're going to do is we're going to start by going into that that naming module, and what we're going to do is we're going to generate a schema from those variables. So we saw that just with this one module that we're using it in, like we're kind of copying all the variables over, and so we're going to say that's a contract. That's a contract that we want to adhere to. So we'll generate that as a contract. At that point in time, you can take your Terraform variables.tf. You can either just delete it or you can keep it. Your call. But like once you do this, you're managing your variables from JSON schema. And so there's input, which essentially takes your Terraform vars and converts them to JSON schema the first time. And then we have this output command here that will actually take the JSON schema and dump it back to Terraform variables, so Terraform understands it. So teams do this different ways. You can either put this command like in your CI pipeline to generate your TF-vars right before Terraform runs. So you can do the validation to vet everything, generate the vars, and then Terraform can run. Some other teams will use like pre-commit or something like that and actually do the airlock output like when you essentially commit. So it's like you're working on the JSON schema, you commit, and it pushes up the vars. It makes the vars for you and pushes it up. So you can kind of do it either way. Just really depends on like if you want to see the vars. Like it's a very easy thing to kind of do or want to do as an ops person who's been using Terraform or OpenTofu for a long time. You're kind of seeing a new tool come in place. It's nice to have them both. But if you want to get rid of an extra file that's generated, you can just yoink that bad boy and then toss this command into your CI. And then the other command that we'll see here is validate. So what validate does is it'll take something like a TF-vars JSON file or a Helm values file, and you can take this schema here, so SS, so data and schema, and you can vet it. So now if I have a VPC module that's output a VPC object, or I've got this application assets module that's output a bucket, I can actually vet before I even run it through Terraform. I can vet, does this adhere to the bucket that we've all agreed is the information that we're going to ship in buckets, right? And this is nice because the kind of stuff that you see in Terraform outputs generally is a bit slop. It's a mixed case, like very similar to the cloud being a mix of ops and dev concerns. The outputs from Terraform are a mix of integration concerns and logging information for the human operator, right? And so this lets you kind of formalize the machine part into these contracts. And then the last thing that we'll do is we will, we'll vet the inputs going in, and then we'll apply the Terraform, and then we'll take the outputs, and I'll show how you can use this in like a CI pipeline to actually vet it, right? So I would actually put this in a couple of places personally. I would put this in your pre-production environments if you're using this, and actually vet that the things that are coming out of these modules adhere to your contracts. That stops you from that same breakage happening in prod, which can be transparent, right? Because Terraform's just going to go green. It's going to say it created the outputs that aren't compatible with all the other modules. Fantastic. So this is what we'll kind of do. So let's get cracking. And so I will say that I'm a bit fumbly with this. So like most of the design that I do is either in the UI of MassDriver, like I just literally diagram everything now because I'm a caveman. And then we have our Mass tool, which does like additional stuff for MassDriver. So I'm usually interacting with this system through like 2 other tools. So this is our completely like open source version. So apologies in advance. I'm definitely going to type the wrong stuff. But let's get cracking at this. So the first thing I'm going to do is, where are we at? I'm going to change into our modules. We go down to this resource naming and tagging, right? So what we saw here was if I grep this main.tf, I got all these variables in here, and everybody saw me copy these variables into my other module, because we kind of have the same interface. It's going to be on all of our modules to enforce this convention, right? So let's crack this guy open real quick. And the first thing I want to do is I'm just actually pull these variables out for now. It's just going to make some stuff a little bit easier for us. So I'll just keep main, and then I'll do a new file, variables.tf. I'll just make this a big boy module and actually follow the rules. One resource in main, and I'll move all these to output. Sick. Okay. So now I've got these variables here. And what I'm going to do is I'm going to do airlock. And you should be able to like brew install this if you're on Mac. I don't know if we have, maybe Chris can answer if we have like Debian apps packages and whatnot. I think we may. But OpenTofu, so you look at the help here real quick. So you can see the different tools it works with: Bicep, Helm, OpenTofu. OpenTofu and Terraform, it both works. We just call it OpenTofu because I don't want anybody to send me a cease and desist for saying the word Terraform. Again, I should have wore a HashiCorp shirt today. Okay, so airlock, OpenTofu, and then what we're going to do is we're going to do input. So we're going to take take OpenTofu as the input and output JSON schema. So we'll just say this module right here, and you'll see it. I don't know how to use it. Oh, it's actually something in my missing. Let's do this. Tofu validate. I think I messed something up. No, it's right there. Missing expression. Expected start of expression, but found end of file. Did I do something funny? Airlock and tofu input. Where am I at? Okay, I got something funky in here. What did I do? What did I do? What am I doing here? What I got wrong? So error file 1 through 1, missing expression, expected start of expression. Did I not knit this? Is that what happened? No. I'm about to phone a friend. Just see something really quick. I know that we don't support. I don't think we support the validations into the schemas right now, so it might have been that. No. Actually, let me get off this dev version. Okay. Okay, let me rebuild this really quick. Had a dev version locally. Oh yeah, lots of changes that I don't have. There we go. All right, let's see if that works. What in the goofy heck? Let me grab something real quick. I'm just gonna make out something goofy in my Terraform. me just try something really quick. One more thing really quick. Okay, well, that's no fun. Let's do this. I'm gonna switch to the actual live Git repo instead of this directory I've working in case I got something funky in here. Let me just. Okay, there must be something just goofy in my. Did Chris pop in? Did you see what?
I'm not here. I think it might have been that there's no types on some of your variables for Airlock to know the types. Yeah, I think so. I don't know. I just tried it locally and it was working, but I noticed your project environment name and team don't have types on them.
Well, there it goes. It worked. It worked when I hopped to the one that I was working through. I got a nice one that I worked through in the Git repo, and then now I'm just like in a temp directory doing God knows what. So it looks like we got it working here. So we'll just walk through it here. But I'll copy these. Nah, dude. Oh no, that's the wrong directory. That's the wrong directory. Hold on a second. Cat variables that generated. Yeah, let's just do this. In case that's it. I'd like to start from scratch so I don't have a bunch of files in here in place. I don't like to cheat. But yeah, I bet that's it. Okay. Okay. All right, let's try this now. Open Airlock, OpenTofu, input, bingo. Okay, there we go. Yeah, so it's just because I didn't have the types on there. We'll tune up that error message.
Yeah, I'll go add a ticket to do that.
Get to it. Go fix that. Okay. Sweet. So what we see here is I'm just outputting it to standard out, but you can see that it took these Terraform variables that I have over here, and it generated just a base schema that I can work with. And so what I can do is I can call this maybe, variables schema dot JSON. I swear I've used a computer before. I've typed before. Doesn't look like it, but I do. Okay, so now I got this variable schema here. Sweet. So now I got this schema here. So at this point in time, I can just kind of you can do tofu plan. Watch tofu plan. Prod, cache, project profiles, right? So this is me just inside this naming module, social team, right? And you can see, okay, it went through and it computed all that stuff. Everything works. That's great. Now, what I can do is popping back over to this main TF. I can now just rip this out. And if I run tofu plan again, it's obviously going to fail because I don't have those variables there. So if I come back to Airlock, so this is what I'm saying is you can either put this in like pre-commit and use your JSON schema as your interface to your variables, or you can toss this in your CI, but you can effectively do variable schema, and this will just output to standard out. So you can see it backs it back out to variables, right? So I can start to have this like richer contract, but I still have Terraform variables to execute so Terraform can run. So if I do this, even though we saw that fail because the inputs weren't there, I can just do vars.tf, tofu plan, and it's going to walk me through the plan again. So I personally like to keep this here while I'm doing this demo, just so I don't have to rerun that generate command. I don't have pre-commit installed. But I'm a big fan of yanking it out in prod, which Chris is not a fan of yanking it out in prod. So that's a fun one. Okay, so let's go ahead and reuse this. So if I come back over to this main TF now, my main application or my main module up here, I'm going to change directory. And I'm going to do the same thing here in just a second. Now, the first thing I'm going to do is, I kind of already know this already, but the one catch with composing these schemas is you don't necessarily want to compose schemas like at a flat hierarchy, right? So if I do have these two formalized types that I'm bringing in, let's say I'm bringing in a bucket that my module needs, and let's say a network. And we've got these formalized types. If I merge them into the top level of my object, they can collide with each other. Maybe bucket has a name and VPC has a name, blah, blah. So what you'll usually want to do is put them under a top level key like network and then have their attributes underneath it. And so I'm going to just prepare for that by moving these project environment and teams underneath a metadata object in my variables, and then we'll just yank these all together. So I'll do metadata type equals object, and then we'll have project equals string. Yank all these, and then this should break now because I've got these all under metadata, but I don't have a metadata problem for that. Now I can come over here and I can say metadata dot. Okay. And now if I pop into this avatar here, now I effectively have something that kind of looks like this, right? Metadata. Tofu plan var file presets. The avatar. And put the variable there, but it has not been declared. Did I not save that? Oh my gosh, I put it in the wrong. Put it in the wrong file. Wrong variables file. I was in that inner module. There we are. Enable notifications, incorrect condition type. I'm just going to yank this for a second. We'll come back to this in a minute. We're going to do outputs in just a second. I'm just going to pull this down so we can focus on this, and I'll fix what I got messed up there. Okay, so you can see now it's nested under metadata. So what I've got right now is I've got a contract between these two modules, but it's not formalized, right? My resource module is defining these 4 things, and I'm saying, hey, my org needs to put these on every single module. But I'm over here like a chump copying it in, make another module, I'm going to copy it in, make another module, I'm going to copy it in, right? And so now what you can do is from here, airlock, OpenTofu, input here. And what you'll see is, so this is now my main module for my application assets. You can see that it generated a variable interface for this whole thing, right? So I'm going to go ahead and dump this out to my variables.json. You see that this pops up over here. Now at this time, I'm just going to rename this to temp because we're going to come back to it in just a second. But if we can do tofu plan, this will fail because I'm missing a bunch of variables. And then if I do OpenTofu output variables.json var.tf. We're back to it. So it's able to generate those both directions. And so now what I can do is I'm gonna yank this var.tf real quick. And what I want to do is I want to pop over here to this JSON schema, right? And so we can see is it's generated this exact same block from this metadata object. And so this is where I can kind of start leaning into some of the power of like formalization. So one of the things that's in JSON schema is this idea called refing. And so what it lets you do is it lets you take schemas from other places and kind of reuse them. And so again, this tool is a schema tool. It does a lot of stuff on schemas. We're going to use it in this one interesting spot right here that works really well for resources. But the other place you typically see this is, let's say that between vacuum and habitable environment and the CLI system JSON schema. Oh, oh, that's Chris talking. I thought it was Robert. I was like, whoa! I was like, what a coincidence. Sorry. So what I'm going to do is I'm going to ref this in here. Now I'm refing this like this inner module that I'm using, which is cool. I don't know there's a lot of places where you end up refing an inner module, except for when it's one of these modules that's so core to how everything works. But where this is cool is like, let's say that I wanted to put this S3 bucket in a VPC. I could actually ref in the VPC output, like the contract that we've decided for our business is how we represent VPC information as it moves in between different IaC tools. I can just ref that entire schema, and I'm going to get this nice, rich object coming in for just a single line of code, right? And so what I can do here is this could be HTTP URL, it could be GitHub, etc. I'm going to go ahead and do modules / I'm going to copy this. Copy relative path. Right. And so now what you'll see is, let me just toss this on here real quick. If I generate that again, so you can generate that again. Now, what you're going to get here is, let me just point this out really quick. This is something we're actively working on, but you get a little bit lower fidelity here. Like this is just putting enough Terraform in place for Terraform to start running, but all of your types and your validations are managed through this schema. Now, if you do complex objects, it will actually type out the entire object. Right now, refs just mark it as an any. It's just a bug that we're going to be fixing soon, but this will actually show the full metadata object once we have that patch in. But if I were to put in a complex object here, like let's say I wanted to do foo, and I want to say that foo has a you can actually see that it'll type out like the whole object all the way down. It'll catch its whether it's required or optional, right? So we're kind of adding more functionality in here around like doing the full types and validations and whatnot. But you see, if you actually hard code it in there, it'll do the full structure. But when you ref it right now, it just drops in any. But that'll be patched in the near future. So what's cool now is I can actually run this Terraform with this. Like this is enough, right? So let's do this one more time. var.tf. Tofu apply var file my presets. Hopefully that doesn't implode on us. And so now what I've done is I've said, hey, for all these places, all right, I'm going to have a bunch of modules using my, whether it's like Cloud Posse null label, or this metadata resource that we've made. I need to use it all over the place, but instead of me copying and pasting those 4 blocks over and over again with this, I can just ref that object. If I'm starting to lean into some more formalized things, which we're about to do with the bucket, I can actually start referencing that as an output. So let's go ahead and hop into the bucket now. That is an error because I don't have IAM policies saying that the bucket can write to the topic. Let me fix that real quick. Okay, bucket topic. SNS topic policy. Yeah, let me just grab one of these. SNS topic, this one down. There we go. That should do it. So it was just, I didn't have the service principal in there giving access. That should. Come on, give me some outputs. There we go. Put bucket notification in response area if it is not supported for notification. Oh, did I spell my event wrong? See, this is where we should have put all the events in that enum. All the events in that enum. Left the old S off the S3. That'll do it every time. I'll do it every time. Werner Vogels does not like it when you call it just 3. Most people don't know this, but he actually has a button on his computer. He approves every bucket creation manually. This hits him, and he just approves your bucket. He saw that S3. He's like, no way. 3? You can call it 3? No way. Okay. There you go. So now you can see we got our output here. And again, like we have a bucket name, which is great. I've also got these policies, right? So these are just 2 arbitrary things that are kind of output so far, like, so I can see them, right? But if I want to start composing this infrastructure together and I want to make buckets, and I've got things that use buckets, whether it's an application or a Lambda, or it's going to get tied into Redshift to do some sort of like copy loading or whatever. I want to start formalizing this. So I'm not copying a bucket policy, copying a bucket name, copying a policy name. Like I actually want to be able to pipe this stuff together without having to go through a bunch of copy and paste fatigue, right? So what I want to do is I'm going to come back over to our outputs here. And what I actually want to do is I want to kind of formalize this a bit. And so what I'm going to do is I've already designed one here. I'm just going to kind of toss it into a directory real quick. I'm going to delete these variables now. They can go away. I'm going to make a new directory here called contracts. And now I'd probably put this, we do this personally. We make just an open source repo where all of our contracts are stored. We call them artifact definitions, but I would put this contracts as like a central place, like a Git repo where all your contracts are. So you can kind of go through different versions of them. Like people can, hey, I want to make a change to this. All the people that are stakeholders and using that resource can give feedback on that and whatnot. But I'm going to go ahead and just add one for bucket.json. And what I'm going to say is, in our team, what we have decided is when we produce a bucket, it's not just going to be an ARN and then leave up to you to try to figure out how to map and figure out where the policies are. A bucket is always going to come out as an ARN and a package of policy, like principal release policies by name that you can pick. And so what I've got is I've got this ARN type here. I've got policies. And then I'm saying you need to at least give one IAM policy with your bucket. So I'm actually putting constraints on the output here. I can't use the bucket if you don't give me a policy to use it. So you need to put at least one. I don't care what you call the key, but I'm going to expect, an ARN on the other side. And so you could also, you come in here, you can actually toss in like additional validation on the property side. I could do like a regex here. What's it called? Pattern, I think. They call it pattern here. We can put on like a regex pattern and make sure it actually looks like an AWS ARN type. And so now what I can do is I can come back over to these outputs and I can do something like this, bucket. Right now, if I go ahead and I reapply this real quick, you should see that it has that structure. Should have used local stack. There we go. So now it's got that structure, right? This is cool. So now I can do something like tofu output, JSON. Getting that raw value there. I can pass this through something like JQ, do bucket.value. Right now I'm actually getting like the raw JSON out of this thing. And right. And so now I can take this artifact that's coming out and you do this in like your CI. In MassDriver, we're actually doing this as a part of like drawing the lines. But you put this in your CI and say, hey, I'm making a series of these different resources that are in their own modules that are invoked, keeping their own state files super small, so I don't have state blast radius. But I want to be able to compose these things together. So I've got a bucket module. It's got its own state. I've got maybe a Lambda that's going to have its own state store. But I want to be able to pass this bucket information into it. Now I've formalized this. Now what's cool is this contract I can use to validate the output. So like this is going to exit 0. So it'll actually move through that step in CI. I'll be like, okay, the thing that you got out is okay. It is a bucket. What's also cool is when this module goes through our pre-production where we're doing like our Terraform test and whatnot, using our presets to drive our tests. On every single one of those, we can validate that it adheres to all of our contracts, right? So now we're using our presets to drive like the blank state problem away. We're using our presets to give better examples of how to get started. We're using our presets to drive tests. And then when we're formalizing our outputs, we can also, in our tests, use these contracts to validate that this isn't going to break prod because an output moved around. And then from here, you can use the same logic to, let's say on my Lambda needs a bucket. I can do just like I did with this variables.json here and ref our bucket contract and say, hey, my Lambda requires a bucket. I don't have to put in 10 different fields. It's going to grab those fields and inject them into my code dynamically. And now I'm going to be able to pass the output of, JQ bucket value directly into my TFR's JSON, right? So I can actually make composable infrastructure that has real contracts around how it works. So let me switch back over here, see if I've got any queues. Awesome. Okay. So that is about it. That is about it. There was one other section I took out because I actually thought we weren't going to have enough time, but we'll just kind of recap on this and I'll mention this one other one that's kind of fun. Maybe it'll be, for anybody who wants to go through the full workshop lab by themselves, I'll add this one to the end of it. But kind of walking through this one more time, the core principles we kind of talked about today is this idea of use case oriented design. Instead of trying to build a module that is specifically for one team's use case or for the entire world's use case, we instead start to think about what are the use cases that make sense for our business, what are the services that we want to support and how will people use them, and how can we kind of cut down the variable interfaces to reflect just that one use case. This is going to give us the ability to actually start doing convention over configuration. Until we've scoped our worldview down to how people are going to be using these services, convention over configuration is just outside of our reach, right? And for people who haven't heard this phrase before, I don't know if it was popularized before Rails, but Rails is one of those things that it gets a ton of shit. Oh, Rails, it's slow. But I mean, if you were developing from 2006 to 2012, like it made a lot of the startups that are huge today, right? Like it was popular for a reason. It was very fast to get building, right? And it was because they leaned into these ideas of configuration or convention over configuration. And so us getting there is hard as ops people. We got to start to embrace software design philosophies while we're making these modules, not just making pretty curl requests for an engineer. And we have to start talking to our team about what we want to formalize in these things and start treating our developers as customers and our modules as MVPs or MVMs, minimal viable modules. I'm going to keep going with that. It looks cool when you write it, so I'm just going to keep saying it. It looks like the Charlie Brown shirt thing. The 7 patterns, embedding logic. So we didn't have a great example of this in the beginning, but I did have that screenshot from the Open Search. The idea is like we have now the ability to put logic in Terraform. We didn't have that for a long time. If you were here in the 0.11, 0.13 days, like we were just winging it in prod, trying to get infrastructure out there. Now we have this awesome tool that allows us to do a lot of really interesting computations, and we need to abuse it, right? Every other software developer out there is using logic to program things and build abstractions. Why are we not doing the same thing, right? It's like the way we go about HCL a lot of times is like programming with just raw JSON. Operational abstractions. So these are the non-negotiables that your operations team, SREs and DevOps and platform engineers have decided, like, this is how we want to run these services in these different, effectively like modes. Survey-based inputs, taking those conversations that we have and the things that we process in our head to figure out what to put into a variable and just making that code. Like it makes us more valuable by spreading our knowledge through software. Use case presets, again, examples on steroids. But I think one of the key things is when you approach these from, okay, I've got a really good module. I'm not just going to show you how to use it. I'm going to show you how to use it for some interesting cases. Gives developers a great place to get started. Gives them the ability to just maybe even just grab that config and go, besides popping in their metadata information. Drive naming and tagging. If you want sanity of consistency, that little goofy module is the key. Definitely check out the Cloud Posse. I haven't had a drink in a while of water. The alcohol I have all day long. That's a joke. The Cloud Posse no label is a really good module. But if you want to build your own, they're pretty straightforward to get started. Gives you a lot of flexibility. And then schema-driven validation using tools like Airlock. I think Airlock's the only thing in the space right now. I'm not sure if there's anything else that does something similar. But there's a lot of stuff that ties into the JSON space. I'll give you a little tidbit. When you see Mass-Driver, actually, does anybody mind if I just show something really quick? Anybody going to be offended? Maybe I'll show you guys prod. I'll show you one of the places that's really cool that you can kind of see this flex. Right here, yeah. So when I come over to this configuration for this database, that is my TF vars. So my TF vars goes through Airlock, generates a JSON schema, and then we take JSON schema and we push it through this tool called RJSF by the Mozilla team, and it generates these really nice UIs. So this is one of the things that we do to kind of give your developers that clickops experience, but like fully backed by IaC. And one of the key things to how our product works is taking these schemas and rendering. So what's cool about this is you can tie this into GitHub Actions. GitHub Actions does support forms for configuring things. You can build your own little, UIs, widgets. Maybe you're building some stuff on Backstage. There's just a ton of power with JSON schema, and it's everywhere now. It's part of Open API Spec v3. So a lot of the stuff that Kubernetes is modeled on when you get down into custom resource definitions and whatnot is based off of JSON schema. It's also an optional thing for Helm, which blows my mind, the amount of effort people put into the comments in a values.yaml file when it actually just supports JSON schemas out of the box. I don't know why people aren't doing that more often, but it's all over the place. So it's a pretty cool tool to learn, pretty cool piece of technology. And we use it pretty aggressively. The one last thing that I did not put on here that I think is really, really cool for kind of pushing self-service fully into developers' hands, making these modules a bit easier to use, is taking those outdated runbooks that we've copied and pasted someplace and actually bringing them in as templates and sitting right alongside the module. What's cool is now that you're thinking about modules in a particular use case and you know how people are going to be using them, you can start thinking of how people will troubleshoot it, right? It's very hard to say, hey, how do you troubleshoot an RDS? Well, it depends. Is it Oracle? Is it Postgres? Is it MySQL? What is it, right? But if my module is use case specific, and it's like, this is a Postgres RDS module. Well, now I got runbooks I can give you on how to look at PG stat statements for indexes and whatnot. And so the other thing that I took out, because I didn't think I was going to have time, was talking through using runbooks and making dynamic runbooks based off of real information. So actually taking these templates that you build and then pushing your Terraform inputs into them to render out markdown files that actually have like copy pastable examples that developers can use. I need to get a list of snapshots because I need to do a database restore for either a preview environment or maybe I got a prod outage. I need to restore some data. Boom, the runbook actually has a command that I can copy and paste in, not a, hey, run this command and put your ID here, right? And so what we do is we just, we've seen is people just kind of do that and then push it into something like Notion, right? Or you can even just push it into S3 and have like a directory for each of your teams where all their runbooks are. Maybe even just kind of push it into your Git commits, using GitHub CI/CD. So that's building developer-friendly infrastructure as code with OpenTofu. I hope it was entertaining for everybody. I hope I didn't misspell too many things. Like I said at the beginning, we do have 2 other workshops. One finishes tomorrow. It was a 10-week, 1 hour a week on getting started with OpenTofu. So it starts from the basics all the way up to getting shit done. We put all of that on YouTube. I'll share the link here. We also have a really funny cartoon because I don't like GitOps. There we go. I'll pop that in here. So if you're newer to OpenTofu, that's a great 10-hour workshop. And there's also a GitHub repo that goes with that, walking through all the code and examples. And then December 18th, I'll share the link one more time here from StreamYard. I'll pop this in the comments as well. So this is another 4-hour workshop, and this one is all on generating infrastructure as code from existing cloud resources. So what we're going to go through is I'm going to deploy essentially like RDS database with some replicas, some security groups, etc. I'm going to use a Terraform module to actually produce all that stuff. You'll be able to take that module, spin up all that stuff as well. Then we'll just delete that Terraform. And then what we're going to do is walk through using a couple different tools and some AI prompts to actually generate a base level module to manage the staging version of that, and then use it to kind of split that code out into TF-vars for each workspace, and then a module that is abstracted across those environments. So if you have a lot of infrastructure that's not in IaC yet, and you want to figure out how to get that stuff in code quickly, I'd say definitely check out the December 18th workshop. But yeah, that's it. Thanks so much, everybody. I know this was a lot of time. I appreciate it on a whatever day of the week this is morning. And if you have any questions, I'll hang out here for a bit. Happy to answer them. Otherwise, find us on LinkedIn or Twitter, MassDriver. Always happy to answer questions. You hop in our community Slack too. We post a bunch of workshops there. And what I'll do is after this, I'll send an email to everybody with a link to the video, the GitHub page, and then the slides. And then I actually have a big outline pamphlet that I've kind of written up on these. So it's a bit more detailed. It's about 20 pages that I'll share with everybody. Thank you, Matt. I appreciate it. Awesome, everybody. Well, I'll hang here for a bit if anybody's got any questions. Besides that, I'm thinking about the burger I'm about to go get. Thanks, guys. I appreciate it. Hey, Chris, can I add you to the stage and just riff with you for a few minutes in case anybody's got any questions?
There we go.
Hey, Andreas. It's good. Am I going to see you tomorrow? I'm doing tomorrow's the capstone for the 10-week. You going to be there? We'll see. Dude, he's late night in Germany right now. He's staying up for this. I love it.
What time is it in Germany?
I have no idea. I barely even know what time it is here. Heck yeah. Yeah, I don't know. I'm not. You know how bad I am at this.
See, it says it's 10:17 p.m. in Germany.
Oh, look at this guy.
Oh,
nice job, dude.
Hey, thank you, man.
Good.
You know what? I'm hungry, tired. So Chris, how did it feel watching me absolutely butcher using air?
well, no, I was worried over here. I'm like, oh, what's going on with this? I was frantically trying to, because I couldn't see your config very well, and I was running all the things locally. I'm like, it's working here, so I was trying to view your